He's going to be talking to us about physical computing with the Raspberry Pi. Give him a warm welcome, please.
Thank you. Welcome, everyone. So my name is Ben. I'm the Raspberry Pi Community Manager working at the Raspberry Pi Foundation in Cambridge. I'm the creator of GPIO 0, a Python library for interacting with the GPIO pins on Raspberry Pi, which I'm going to be talking about in the talk. I write a column for opensource.com, a community project that does all sorts of tutorials and articles and things, and so it's well worth checking out. There's lots of great material on there. There's my GitHub handle and Twitter handle on there as well, and you can reach me by email. So we've sold over 14 million Raspberry Pis around the world now, so things are going really well. So I mean, I was looking back at some of the slides I made the first EuroPython I spoke at, and we were sort of about 3 million at that point, and that was seeming really big, and really like we've made a real big impact in the early days, and it's great to see how far we've come. And similarly, the actual number of staff on the foundation team has grown rapidly over the last couple of years, and there was a slide I had with 3 or 4 people that were the foundation at the time. And now we've grown to this is from just a week or so ago. We had an all staff to get together, and it's great to see all the great things that we've been doing. We were founded in 2009. We only started sort of hiring people around 2011, 2012. The Raspberry Pi Foundation incorporates 3 organizations now. The trading company that makes and sells the Raspberry Pi computers. There are people who work in the foundation that are sort of purely on the education side of things, but then there's also Code Club and Coder Dojo, 2 sub-organizations that we run in providing opportunities for young people to get involved in programming, learning about technology, learning about computers and digital making all around the world. The Raspberry Pi trading company operates as a way to feed their profits into funding our educational programs. That's how our business model works, and it's doing really well, as you can see. The Raspberry Pi Foundation's mission is about putting the power of digital making into the hands of people all over the world, so that people are capable of understanding and shaping an increasingly digital world, able to solve problems that matter to them, both as makers and entrepreneurs, and equipped for jobs of the future. Now, that doesn't just mean people learning to be software developers, go and work for Google and Intel and people like that, but actually preparing people for a better understanding of technology, whatever field they end up going into work in. And we do this by providing low-cost, high-performance computers. We run education programs and do a lot of outreach activities. We provide free resources for everybody, and provide teacher training, both in person, so people can apply to come on one of our training courses, and we actually deliver training online, so anybody can join in. We're not limited to the number of people delivering the training in the team. Take a look at the current models of Raspberry Pi. Again, this is something we've come a long way since my first EuroPython talk, but the Raspberry Pi 3 is our sort of main headline product. It's a 64-bit quad-core ARM v8 running at 1.2 gigahertz with a gig of RAM, and that's our $35 product. The main product that we sell has always been $35, so over the years we've improved the quality and the power and the spec of that main headline device, and this is but keeping the price the same. So that's where we've got on the main product. A couple of years ago we introduced the Pi Zero, which is a $5 version of the Raspberry Pi. It uses the Raspberry Pi 1 chip at a faster clock speed. So you've got a gigahertz there rather than the 700 meg that the original Pi ran at. It's got half a gig of RAM, and that one's, as I say, that one's $5. Not as powerful as the Pi 3, but certainly really useful in certain maker products and projects that you can embed something you want to embed the Pi inside. We recently introduced a $10 variant which has Wi-Fi and Bluetooth, so a lot more scope for connectivity in your projects as well. So that's where we're at on the product side. And in terms of the software, so again, in sort of 2012 when the Pi came out, we were in a place where we had a sort of bog standard LXD theme, looked really, really traditional Linux desktop, and we've done a lot of work recently on improving that and making that skin look really nice, but still be really performant. It's a very basic sort of thing. There's no 3D acceleration or anything special going on there. It's just doing what it does well, providing you with access to the education tools and some of the software and things in there. It's looking really nice, a nice set of icons and things. We also recently released this operating system for desktop PCs. So we provide an x86 image you can download. You can run in VirtualBox or stick it on a USB stick and actually run a live image on a laptop or PC or Mac. So you can actually boot this up and get the sort of near enough the same experience you'd get in terms of software on the Raspberry Pi without the additional hardware and the physical computing I'm going to be talking about. But actually get access to things like Python and other software tools and other programming tools in this isolated environment that you can boot from a USB stick. And if you really like it, you can install it as your main operating system. We've talked for a long time about moving on from idle, which is the main education-focused editor provided. It's actually sort of bundled with Python if you download Python from the Python website. So we've talked about for a long time about moving on from this and finding a replacement, finding something more suitable. As an intermediate measure, we've introduced a new IDE called Thonny, which is now pre-installed in Raspbian. Idle is still there, as a lot of textbooks and things sort of point to that, but and it does work to a certain extent, so it's still useful. But there's an alternative there. It's a Python 3 only editor. There's no options, which is really helpful for education. And it's got some great debugging tools and various other features. But on longer term, we're investing in developing the Mu editor that Nicholas Tolliver has been working on. So we're working with Nick with a list of specifications from our feedback from teachers and some of the teachers that we have on staff that are feeding into what a Python editor should look like for education. And it's something that kids and teachers will start with, and they may move on to more complicated, more complex IDEs, more powerful tools, but we hope that this is a great start. You can read about that on Nick's website as well. So going into physical computing, so the main aspect that makes the Raspberry Pi different from regular computers is the GPIO pins. That's the general purpose input-output. There's a bank of 40 pins, and you can see there's a little port label there that labels the pins that have different purposes. So physical computing is all about connecting up flashy lights, motors, robots, sensors, photo, video, and enabling you to get into the Internet of Things, do home automation, and physical projects. So if you take a look at that bank of GPIO pins, this is what it looks like. This is a little handy guide from a website called pinout.xyz, which is a really useful reference if you're hacking with a Raspberry Pi. So they're mostly 3-volt pins. There's 2 5-volt pins. If you want to do something with robotics and motors, you'll probably want a 5-volt supply. The GPIO pins are all numbered, so you can individually trigger certain pins by their number to go high or low. And they're variable 3v3, they're 3.3 volts. We also provide, there's also a set of other protocols you can use that for high-speed data transfer buses and things like that allow you to do more complicated than just turning individual pins high and low. You can actually do a lot more by sending data at high speeds down the pins using these different protocols. So there's various ways you can sort of access the pins. You can either wire things directly to the pins or use a breadboard. Actually make up your electronic circuits by connecting things directly to the pins using jumper cables. So you can do something like this. And people also make accessories that actually place on top of the pins that sit neatly on, a bit like an Arduino shield if you're familiar with that kind of thing. We have this standard called HAT, which means hardware attached on top, and it's for the 40-pin header and it sits neatly on the Pi with mounting holes in the right place, and it's designed to just be a sort of neat sort of standard way of providing add-ons. And there's also you're expected to have an EEPROM on a hat, which is a way of you can program a device to tell the Pi tell the device tree what is attached, so that it can do something according to what hardware is attached. So if you used any GPIO in the early days of Raspberry Pi, there's a library called RPi GPIO in Python. There's a very low-level library, and it was used for 3 or 4 years as the sort of main way, the canonical way of doing GPIO programming, from everything from flashing LEDs to robotics and sort of IoT home automation stuff. It's quite verbose, lots of boilerplate code, and so one of the things that I worked on was this GPIO 0 library, which abstracts away the components and the devices into these classes that you can easily write code which talks about what you're doing with the devices rather than what you're doing with the pins. This makes it a lot easier, so you get something like this rather than the sort of sending pin numbers that you keep passing around high and low. Actually talk about what you're doing to the device, in this case the LED. And then you even get into things like this, where you have a threaded blink, you have a blink thread sort of running in the background, which just means you can hack on more devices much more easily and get going with your project. The GPIO 0 library supports all sorts of different devices, everything from sort of basic components, buttons, LEDs, ultrasonic distance sensors, analog digital converters, remote control sockets, traffic lights and robots and motors, servos, and a few different sort of bespoke hats and add-on boards that we provide composite device classes for. So there's a great, this isn't even in the latest version actually, but the device hierarchy in GPIO 0 is quite interesting. It's all in the documentation if you want to take a look. So one of the great things about the way that GPIO 0 allows you to get started is you can start with really simple code that's very easy to read and write and understand. So if I wanted to get an LED connected up to a button so that the button actually activates the LED, and I'm starting with a child or a teacher who's doing this for the first time, I would show them to write something like this. It's very simple to understand procedural code. You can progress onto other paradigms. So looking at event-driven programming, you do the exact same setup where you've created your LED, you've created your button, but you have it fire off these events based on when these things happen. So when the button is pressed, it fires the LED.on method. When released, LED.off. And then you can go off and do something else. You're not stuck in a while loop. And you can even progress onto an even shorter version of code where you're using the declarative paradigm. And again, all of this just happens in the background in threads. Setting the source of the LED to the button, the values of the button, does the exact same as both of these other examples. But it's in a declarative way, you've declared in one line how the devices should behave. And there's some really interesting stuff you can do with this paradigm. So just to explain how that works, if we got a device like a PWM LED is actually just a regular LED that you configure to use pulse width modulation to control the brightness rather than just turning it on and off. And if we inspect LED.value, we can see that that's 0. So rather than being true or false like a regular LED would be, a PWM LED has a 0 to 1 value, which is the level of brightness. If we run LED.on, we actually change that, and then we inspect the value. It's now changed to 1, but you can also set that to 0, which will do the same as running LED.off. So that's what .value is. And what you find is that if you have two components that have the same value set, so like 0 to 1, so a potentiometer connected to a rotary dial connected to an analog digital converter chip, the MCP308, they both have a value 0 to 1. So things like LED and button both have true-false values. You can pass one into the other. So doing this LED.value equals pot.value sets it once, so that the LED brightness matches wherever the dial is at that given time. And what you end up doing is writing while loops like this to say, oh, I always want the LED to be, the brightness of the LED to be controlled by the potentiometer. And so this is where the source values thing comes in. So everything has a dot value, whether it's an input or an output. And then they also have a dot values, plural, which is a generator. It's just a generator constantly yielding the current value. So every time you ask for it, the next one you get the dot value. Devices that can have their state set, their value set, have a dot source, and that's just a way of saying, where do I get my values from? So you can pass in, like the most obvious case is to pass in the dot values, because it just takes any iterator, so in this case an infinite generator yielding the value of the device into the other device, and it just means that they're connected, which makes this work. You can also process values in between as they come out of one device into the other. So you can write your own function to do something in between. We also provide a set of commonly used tools, so things like negated is an easy example. So negate the Boolean value as it comes out of the button, pass that into the LED. It means you have reverse logic of when the button is not pressed, the LED is on. When the button is pressed, it's off. You can also combine values. For instance, if you have 2 buttons and an LED, and you want the LED to be on if both buttons are pressed, then you take both sets of values and them essentially using this all values function. And you can do this with any number of devices. And as long as all of them are true, or both of them in this case are true, then the LED's value is true. So a really neat way of creating an AND logic gate using GPIO components and just a few lines of code. A couple of other examples using the same sort of paradigm. We have an LED bar graph class. So that's the idea that you would have several LEDs in a row, and as well as just being able to there's a class called LED board, which is just a series, an arbitrary series of LEDs. LED bar graph is one where you can set its value from 0 to 1, and rather than arbitrarily index LEDs, you set the value 0 to 1, and it lights up that many LEDs up to the maximum. So if you set it to 0.5, half of them will be up in a bar graph sort of sense. And so we have another class called CPU temperature. So there's a few classes in the library that are what we call internal devices rather than sort of GPIO components, but they have the same properties and they can connect up to other devices. So CPU temperature, you can read the temperature, like it's a temperature sensor, actually get the Celsius value. But you also get a dot value of that, which is a 0 to 1 on the scale that you've provided on the init. So if it's halfway between 50 and 90, for instance, then your LED bar graph will be half lit, and you can see that go up and down as you do different things on the device, as the CPU temperature is going up and down. And similarly, one called ping server, which just runs a ping and returns a true or false value of how the ping went. So you create a ping server on google.com. Another thing you can do is set the source delay, which means how often it goes and looks for the next value. If you don't want to be pinging Google as many times as you would be reading a potentiometer value or something, if you just want to do this once a minute, you'd set the source delay to 60. Set the value of the green LED to equal the Google values, and set the red to be the opposite of the green LED. So as well as doing negated Google values, instead of negated Google values, I'm just negating the actual LED rather than looking at that up twice. So either the green is on or the red is on according to whether it can ping Google successfully. Just a little status monitor. There's an add-on board called Energini, which is a little remote control socket the add-on board talks to via radio. This is, at home I have a pet tortoise, and this is another internal device class, the time of day, that you set up and say, this time of day is active between 8 a.m. and 8 p.m. And then you say that the lamp, which is connected to the Energini socket, should be on between those times. And again, you could use the procedural paradigm for this and just say, while true, keep checking, or something like that. Or use the event-based, that when this time is activated, then run this function. But this is another way of doing it. Another thing that we do is support multiple pin libraries. So when I said before about RPyGPIO, this is the one that people were choosing to use. So previously, if you wanted to use a different library because it had a specific feature that one of the other ones didn't, you would have to rewrite your code into that library. What we do is we provide multiple backends. So you just elect which pin library you use, and you get the features of that library. So RPyGPIO is the default. It's sort of the most commonly used and in some ways the most stable. That's installed by default in Raspbian, so that's the one that's by default elected to be used. There's a couple of others, other GPIO libraries that we support. And we also provide a native pin implementation, which is kind of experimental, but it works for basic things. But it's fallback if you haven't got anything else. And there's also a mock interface, which we use in our test suite, but it is quite handy for being able to just test that your code is sort of valid. And both of these, the native and the mock pin, are included in the library. You don't need an extra module like you do with the others. So PyGPIO is one of the libraries. It's implemented in C and runs as a daemon on the Pi. It will allow remote socket connections that control the GPIO pins. So using the GPIO0 API and the nice code you can write, you can actually control a Pi over the network and actually run this from your PC, as GPIO0 could be installed on any machine because it can be used in this way. It doesn't have to be a Raspberry Pi, but it can control the GPIO pins of a Pi using the PyGPIO daemon. And so, for instance, there's one way of doing it is if you use the PyGPIO factory to create a sort of connection to a Pi that has the daemon running. And rather than creating an LED just on a pin number, you associate it with that device, so with that pin factory, and then the rest of the code is exactly the same. And alternatively, with some code that would, like on the right here, that would be used normally for using the pins directly on the Pi, you can actually, so yeah, with that exact code that unchanged, just with some environment variables set, you can actually have it execute the GPIO commands over the network. So you could change that the IP address there before you run it again, and it would execute the same code unchanged on a different device. Here's just an example of using mock pin. So I do this quite a lot on my laptop just to test that some code over it and some documentation or something is accurate. So if you launch the pin factory mock and then open your Python shell, you can import something from GPIO0, create an LED. Here's an example where I've just said LED.blink. I've inspected the value, and then a second or so later inspected it again, and you can see that it's in the background. It's doing all the things that the devices should be doing. And as I say, we use this in our test suite, but it is quite handy just to be able to test your own code without wiring up components. Another thing you can do is you can drive the input pins. So if you created a device which is using an input pin, you can tell it, because there's no way of telling it that there's no way of actually pressing a button that you've created in that's connected to a mock pin. But if you access the pin and drive it high or low, you can actually affect the state of that button. So again, this is how we test things in the library, but really handy just to be able to test out. So in the next release of GPIO0, we'll come with this handy pinout command line tool as well. So one of the things we do is inspect the device you're on, to sort of find out some information about it and what sort of pins you have, what hardware you have, and allows you to do, will warn you if you can't do something, if you try to access a pin that your model doesn't have or something like that. And we use that bank of information to provide this command line tool. So regardless of what model Pi you're on, it will show you the pinout for that particular device, and a little ASCII art diagram of the Pi itself. You can also request to look at other models by looking up their revision code and seeing what the pinouts or what the spec of one of the other devices is, one of the other models. And so one of the most popular hats out there is one that we make called the Sense hat. We made this especially for an educational program. There are 2 Raspberry Pis on the International Space Station with one of these sensor boards attached, and they're in these great space-grade aluminium cases. They went up with British astronaut Tim Peake for this Astro Pi mission. This was an opportunity for children in schools in the UK and later all around Europe to write code in Python which would be run on the space station. The board has a bunch of sensors, so you can look at the temperature, pressure, humidity, pressure, accelerometer, gyroscope, magnetometer, and there's an LED matrix that you can program, and there's a little joystick that you can use as input as well. So it's a really great board for all sorts of different purposes. So it just goes on the Pi directly like that. That's what I was talking about hats earlier. So just a couple of examples. So you can scroll text across these the LEDs. You can scroll text across it, or show letters, or show information on there, or just arbitrarily access the pixels individually and make your own patterns and icons. You can easily get access to the sensor data just by reading the properties on the object, and you can do stuff like this where you show a value of one of the sensors in terms of which LEDs are lit. So have a kind of a bar graph, if you like, of LEDs according to something like the temperature or the humidity. And so the AstroPi program will be in its 3rd year this year, and we'll be on our 3rd astronaut that's run the program. So Tim Peake from the UK, Thomas Pesquet from France, and then there'll be another European astronaut running the program in the next term. So this is a competition that any kids from schools in Europe can enter, and there's various different levels of what they can do. They don't have to do anything too complicated, but anything from tiny little scripts which interact with the astronauts, or show them messages, or read the sensors and tell them something, or a game that they can play, or something that they can interact with. We've had some really interesting entrants, and some of them are doing some really cool sort of science experiments and actually logging the data and then running the experiments again at home to compare the results and actually thinking about space. We actually have 2 emulators for this. This is one of the things we did to try and engage more people into the program, actually, without having to buy Raspberry Pi, without having to buy SenseHats, or even if a classroom only has 1 or 2 that are real hardware they can use, the rest of the class can participate in this. So on the website trinket.io, which is really great on its own for doing Python stuff in the browser, there's actually a special mode of it that if you import the SenseHat module, it brings up an emulation of what the SenseHat looks like, and you can program the LEDs using exactly the same API, or using their Python in the browser. You can also use the sliders. So this is a really good way of just testing your code as well, that if you write some code that says when the temperature gets over 80 degrees, this should happen. There's no way of easily sort of getting your Pi to read over 80 degrees, so in order to just test it, you can do something like this. There's also a desktop emulator that comes in Raspbian, but you can install this on your PC as well, run it offline. Again, you can access the joystick and the sensors and control the LEDs. Really good way of testing your code out and having a go at doing something like a science experiment without having access to the hardware. So you can enter the competition with just having used this freely available software, or the Trinket web service. The Pi camera is one of the other really interesting things about the Pi. So the Pi has a CSI port for connecting up a camera module, because the Pi originally came from a mobile phone chip, and it had access to 2 cameras for the front and back-facing camera. And so using one of the sort of camera modules you would get in a mobile phone, you can actually access the camera, do photo and video in 1080p, full HD photography, but actually use your programming to control when pictures are taken or change the configuration and settings in real time according to sensor data and things like that. There's a basic command line interface that you can use and a brilliant Python library that has a really nice API for controlling the camera. As an example, just some Python code that would capture an image and record video. And if you want to hook it up with some GPIO components, say wait for a button to be pressed before taking a picture. Again, it's just very straightforward. It should feel very familiar if you've used any sort of neat Python APIs before. There's a lot of interesting stuff in the library that you can access that the PyCamera gives you that are really interesting to play with. So there's a whole list of image effects that it allows you to use, so you can kind of do interesting stuff like this. Use all these different image effects, and you can also stream over the web quite easily. So one of the recipes in the PyCamera documentation shows you how to do this, and there's a sort of more complex version in this GitHub project that's there's a really interesting way of being able to stream your camera footage over the web. This is the second project that I have on the Pi that's connected to my tortoise table. And there's a lot of people doing really interesting stuff with PyCamera and OpenCV. So this blog, pyimagesearch.com, is full of tutorials and setup guides and things on how to do facial recognition and object recognition and actually learn about that kind of area using the Raspberry Pi and OpenCV using PyCamera. So do take a look at the documentation for some of those projects. The GPIO0 docs are on Read the Docs, and you've got the SenseHat library, and SenseEMU is the desktop emulator, and then PyCamera as well on Read the Docs. They all have really good documentation. So we have a magazine called the Magpie. You may be familiar, and we once gave away. The Pi Zero came sort of on the front cover of the magazine. It was the first time a computer magazine had ever given away a free computer with the magazine. And we do some really interesting stuff with the magazine as well. It's out every month, and there's projects and articles and interviews and things. 100 pages every month, and it's really great. But we do some really interesting things like the giveaway with the Pi Zero, and one of the things we did recently was we teamed up with Google, and they put together they made a hat called the Voice Hat, and you've got this cardboard foldable container that you put the Raspberry Pi, the hat, and a speaker inside. It has a big button on the top, and you essentially make your own, sort of Google Home Assistant. So you can speak into this and have it process your thing. Use the Google Assistant to give you an answer the same way you would ask your phone or ask your one of these devices at home, ask it a question or ask it to use something, some web service or something. But you can also write Python code which processes the commands, the voice commands, and you can use custom commands to do stuff, which could include, say, GPIO stuff or camera stuff. So turn the lights on or make the robot go forward, take a picture, that kind of thing. So some really interesting projects people have been doing with that recently. And you can check out the stuff on our blog and in the Magpie's blog, and some follow-up articles in the Magpie as well, and on the AIY Projects website. That stands for AI Yourself, Artificial Intelligence Yourself. It's a really great project that Google did. So one of the things I just want to mention briefly is is a little side project I've been working on. I gave a lightning talk on it yesterday. You can check out my slides online. Is that based around the problem that PyPy doesn't support uploading ARM wheels. So when you actually, Python wheels, if you're not familiar, the way of providing pre-built binaries for your Python packages, and you can upload pre-built versions to PyPy, but if they're written in C, then they have to be, when they're built, they're compiled for the architecture that they were built on, and so you have to provide one for each type of architecture you want to support. Windows 32, Windows 64, Mac, Linux 32, 64, and so on. And ARM is a completely different platform. So even though you can actually build wheels for ARM that run on the ARM architecture yourself, you can't distribute them easily using PyPy. So what I've done is written some software which automates building of all these of all the packages on PyPy and provides them in a repository that you can install from. So yeah, check out the more details in my speaker deck, or come and speak to me about it if that sounds interesting to you. So there's lots of different ways you can get involved in all the stuff I've been talking about. So one of the great things is, if you have Raspberry Pis at home, or if you choose to buy them, anything you do with it, I mean, making projects or just learning stuff yourself, or getting into the electronic side and the physical computing side is really great. And we love to see more people learning in things that they wouldn't otherwise be learning, and actually doing some really interesting stuff. You can also contribute to some of these libraries that I've been talking about. It'd be great to have some more eyes over, cast some more eyes over some of these projects, and help other people upgrade their modules to Python 3. That's a real problem for us sometimes in the education world, when we're trying to use Python 3 and we end up getting stuck and having to go back to Python 2 for a specific module that hasn't been ported. There's been some really interesting open source projects and Python libraries for Raspberry Pi, things like PyCamera. So yeah, anything like that you're interested in making, or, we can end up using in our educational resources, because that's where the inspiring projects come from. So yeah, do take a look at the source code for some of these libraries, and if you want to take a look at contributing, that would be really great. As I say, I mentioned the Magpie. So this is a magazine you can buy in the shops, but you can also download for free. It's one of the things we do, try to get our stuff, the stuff that we do, the educational programs, the hardware and the software, out to as many people as possible. That's why we write the emulators. It's why we provide the x86 image of our distro. We provide free PDFs of the Magpie as well, and we do a series of books that we also sell. And we encourage people to try and pay for them if they're able to, because it helps fund our educational programs the same way the Raspberry Pi sales help. But you can also download them for free, so they're freely available. If you want to run workshops, you want to go and do something like this in the community, this kind of thing is really great, a great resource, as well as the resources on our website. So one of the things I'm involved in a lot lately is the network of Raspberry Jams. So these are free community events that anyone's allowed to set up, so they're completely independent from the foundation. We just promote and support them. There's a lot of family-friendly events, so they're not necessarily kind of tech user groups, like maybe you have Python user groups at home. But some of them are, which is great as well, but a lot of them are sort of focused around not just kids learning, but for anyone to get access to having a go and learning some programming skills and learning about technology through digital making. There's a guidebook available that I put together that helps people start their own Raspberry Jams, and you can contact me about setting one up as well and get some support from us. So do take a look at the Raspberry Jam page on the website, which has a map of where all the jams take place around the world. So have a look if there's one near you, or if there has been one near you, and maybe you could go along to it, or if you have kids, take them along to it and learn with them and actually work together. There's some really interesting stuff that you see a lot of families doing together at these events. And Danielle will be pleased to see a few of those in Africa as well. So Code Club, as I say, is one of our projects. So this is a really easy way of doing some volunteering that has a really big impact on local children. So if you have kids in school, You can go along to their school and say, I'd like to run a code club. There's projects provided, so you don't have to come up with your own, you don't have to write your own materials. You can use some materials that have been created by educators at the foundation. There's training and support provided. And if you just want to try and do your bit to try and help kids learn, write their first lines of code and do some really interesting projects, then this is a great way to get involved. And there's information on the Code Club World website about the different initiatives in different countries around the world. We also provide a means for you to contribute translations, so we can actually reach more people with our materials as well. So that's something, you can get involved with. And that's all. Thank you very much.
Right, thank you very much for the talk. We have a few minutes for questions, so any questions?
Do you know off the top of your head of any specific projects that need help porting to Python 3?
There was one that was my go-to one that's just been ported, which is really good news. I can't think off the top of my head. We're getting better, aren't we? So it's that's good. We should perhaps make a sort of Hall of Shame type thing for Raspberry Pi specifics, but okay.
Do you know of some industrial projects, including the Raspberry Pi, or would you recommend to do that?
Yeah, we sort of sell Raspberry Pis into three main markets. The industrial market, where people are using them in automation in factories and things like that, into the hobbyist community, people making projects at home, sort of thing you'd see at Maker Faire, and into education. So three very distinct and very interesting communities. In industry, you see, so we actually use Raspberry Pis in the Raspberry Pi factory to test Raspberry Pis. So as they come off the production line, there's a Pi that just does a basic electronic test to make sure it's come out right. Arduino actually do the very same thing. So they have a Raspberry Pi at the end of the production line, and they do some electronic test on the Arduino to do the same thing. And we see other people doing similar things with their own products. You see a lot of people actually building a product around the Raspberry Pi, either the single board computer that you would buy, the $35 one, or the industrial compute module that we provide, which is a Raspberry Pi chip in a sort of embeddable form factor that you can build your own I/O board. And if you're building a smart TV or something and you want it, you want a well-supported sort of Linux platform in the TV, then you can build a baseboard and have as many HDMI ports or whatever else it is that you want, and put them in exactly where you want them, build your products around it, and then buy the compute module and just slot that in, and you've got sort of all of the hardware support of Raspberry Pi for free. So there's lots of people doing things like that. So one that comes to mind is a big company called NEC, who make big stadium TV displays. They're actually shipping 70, 80, 90, 100-inch TVs with the compute module embedded inside them. And one of the things about that is that you can design a board like that for today's Raspberry Pi, sort of whatever the model is at the time, and any future upgrades of Raspberry Pi, when the compute module becomes available, you can start shipping those ones instead without having to change anything. So it's just it's actually a SODIMM like RAM connector. So the device, the module, just slots in to a baseboard that supports that sort of well-supported hardware component. Yeah, there's lots of things like that. Yeah.
Okay, we have time for one more quick question.
An extension to the last question, what about real-time programming with a Raspberry Pi? I guess with Linux and especially with Python, you are not able to fulfill hard real-time requirements. So is there any alternative that you know is typically used, or are there plans in this direction, or is
Yeah,
this
so-
completely out of scope?
No, so there's definitely a ways that you can use a Raspberry Pi in a project where you need the real-time, real-time stuff. So a good way of doing that is pairing it up with something like an Arduino. So if you sort of want to be able to write your programs in Python and or something like that, something high level, or maybe they talk to some internet, some web services, or do something like that that you couldn't necessarily easily do with an Arduino on its own. But actually write all that logic and all that programming in on the Raspberry Pi, but then send off the bits that you need doing real time to the Arduino or any microcontroller. So that's something you see a lot of people do, is they say like, oh, I did all this, this, and this in the Raspberry Pi, but the such and such, the things like NeoPixel grids or something where you need precise timing, and if you've got like loads of other programs running, there's a chance that the timer will go off or something. Whereas ship it off to an Arduino, tell that what to do, and let that do the sort of heavy lifting on that part of the project, but actually still controlled by all this stuff and written in high-level languages like Python on the Pi. That's one option. A lot of people prototype with stuff like this as well, and then perhaps they'll do a proof of concept using a Pi, but then the real product will use something else. So there's a few different options. Yeah.
Okay, we're out of time. Thank you very much for talking again.
Okay. Cheers. Timing was
it's on. For our next session, we have Ivan Smirnov, and he's going to be talking to us about PyBind 11 and using C++ and Python together. Give him a warm welcome, please.
Hello everyone, my name is Ivan, and I'm a quant at a trading firm called Susquehanna in Dublin, Ireland. And I'm actually surprised to see so many people here, given that there is a competing talk on Python going on right now in the main room. So thanks for coming. And today I'd like to talk about C++, which may seem like a weird choice of topic for a Python conference, but I think it's pretty relevant and interesting, and that there's been a few good talks this week on CPython and CFFI and on PyPy. So I think it fits in quite nicely, and I hope you'll enjoy it. So let's talk about Python extensions. So what exactly is a Python extension module? And by Python, I really mean CPython here. This Python extension module is something that you can import from Python, but it's not written in Python. And that normally means it's written on C or C++, because CPython provides a C API. But these days, you can also write extension modules in other languages like Rust or Go. So why would you do that? And the main reason usually is to be able to interface with other libraries. So maybe you want to use some part of TensorFlow that's not been wrapped in Python yet, so you can do it this way. Or maybe you write your code in C++ and you want to interface with that. Another thing is, a pretty common reason, is writing the performance critical code, so numeric code. That does number crunching very fast, and then you can expose it to Python. And the two less obvious reasons that are really important, that I found really important in my own work, are these. So if you have non-Python libraries, like written in C++, for example, you can mirror the API in Python literally one-to-one. And this lets you prototype things very fast, like in Jupyter Notebook, for example. And then you can just translate it back to C++, just add the semicolons, basically, and change the for loop syntax. And if you do that, you can also run the test in Python. It's not that you can't do that in C++, it's a lot easier. There's like very nice test frameworks. And if you're testing numeric code, it's very nice to be able to use NumPy and Pandas and all the other tools. And the last 2 points actually play well together. Like you can start prototyping things and then write tests in Python, and then translate things back to C++, but your tests just stay the same. So, which confirms that you did it right. So it's possible to write Python extensions in pure C, and there's been quite a few talks on this as well. But if you go in this way, you need to have a few skills. Like you have to be good at ref counting, and I don't think anyone's good at ref counting if your name is not Larry Hastings. And there's exception handling that you have to do manually, and by that I really mean like C-style error handling. You have to be able to type fast and have a good keyboard, because you'll type a lot, and you'll make some errors. And if you don't make some errors, then this Python core devs will change the API and make them for you. So that's quite a lot of pain to go through. So here's an idea. If we can translate Python into Python C API calls, why don't we, instead of running that, why don't we just translate it back to C? And then we can augment Python with this fancy new syntax, so we get like fun pointers and references and all that. And it kind of works, and there's libraries that use that heavily, like scikit-learn and pandas. Like the most numeric intensive routines are actually written in Python. But there's a few problems with that as well. So first, you're not writing C and you're not writing Python, and that's actually, at times, it's really hard to figure what is it you're writing. And as I've just checked a few days back, a two-line Python module generates 2,000 lines of C, so it's quite a lot. You have multiple build steps. The IDEs usually choke on that. It has limited C++ support, so it's like stuck in 2003. It has a few new features supported, but most of them are not. And it has limited support for metaprogramming generic types. You have to create stubs for everything that you use from C. And so I think it's good for wrapping a few functions, again, kind of like Pandas does it. It's not so good for managing huge code base. But my biggest gripe really is this. There's just debugging compiled Python extensions is just complete pain. And I just want to illustrate that real quick. So here we have a function that does nothing, but it does this nothing n times. Right, so I'm pretty sure if you pass it to PyPy, it would just not generate any code at all. So if we run Python on that, then nothing good happens. So this is the code for just one line, like for I in range of n, where we told Python that n is an integer, so like what could I be? And so you would expect like a C for loop. I'm not going to zoom this in, there's nothing interesting in there, it's just a bunch of Python C calls really. And so what's wrong? Turns out that I forgot to tell Python that I is an integer. For some reason I had to do that. And then it generates, it's still not nothing, it's something, and it looks pretty bad. So if you were to, but you can actually see the for loop. But if you were to debug this in like step through in GDB, it would be just a complete pain. So here's another idea. Let's use Boost, and Boost is just a humongous C++ library that does everything. So if, you know, if C++ could make coffee, there would be Boost Coffee library for it. And there's a Boost Python written by Dave Abrahams, who's also the author of Boost MPL metaprogramming library. And the problem with that is that you have to build it. And depending on your platform, that may or may not be easy. It also requires Boost, which is, the last time I checked, was 1.5 million lines of headers. And it uses weird tools for building, and then it requires on this, because Boost is compatible with everything, like all old compilers, it doesn't use the new language features, so it uses its own like metaprogramming library. So it takes a very long time to compile, and you end up with huge binaries, and it doesn't attract new contributors because it's really hard. Actually, you have to know the entire Boost to do anything with it. And just a disclaimer: this is not a talk on like Bash and Python or Boost. They're both really good options. If you're already using Boost, then Boost Python may be like a really good choice, or Python is a really good choice if you're just wrapping a few functions. And so I just wanted to introduce another library, yet another library it's sort of like Boost Python, but it does things in a more lightweight fashion. So it allows you to interact with Python interpreter or embed Python interpreter in C++ code. So it's header only, no dependencies, doesn't require any build tools. It's very small, it's like 5,000 lines core code base. It's optimized for binary size, compile time. So we've seen one of the big projects converted from Boost Python to PyBind went down by a factor of 5 in both binary size and compile time, so that was quite big. We support GC, CLang, Visual Studio, Intel Compiler, Linux, Windows, macOS, CPython 2.3, and PyPy. And yes, I really said PyPy. We require C++ 11, but some new features from C++ 14 and C++ 17 are also supported. There is support for NumPy without having to actually locate and include NumPy headers. There's support for embedding the interpreter, and there's a whole bunch of different functions and like features of C++ that we support. And here's a link to the GitHub repo. So I'll just try to walk you through that using a few examples. There's not enough time to cover all of it, but I hope you'll have a good understanding on how it works. So we'll start with a simple hello world example. That's what you normally do when you learn like a new language or framework. And a few prerequisites, you need like a CPython or modern PyPy, and you need PyBind 11 package installed, and some non-ancient compiler. And in all code examples, I will skip this like 3 lines, so it's basically including the PyBind header, then aliasing it to the namespace to just Py, and also defining the PyBind module, which is like the main extension module. Okay, so whenever there's a variable m, it just means the module that you're currently defining. All right, so let's write a function that adds 2 integers, like in C or C++. So here we have a function add that takes a and b, returns a plus b, And we can call the def on def method on the module and tell it, hey, here's the function called add, give it a pointer to the function, and you can give it a docstring and a whole bunch of other things, so it knows how to generate a Python signature. That's pretty much it. You compile it, it works. You don't have to tell it what's the exact signature is. It's all inferred from the type. So it's using the C++, like the modern C++ like type inference features. Or you can even write it like this. You don't have to define any functions at all. You can just use a lambda, a C++ lambda. So you just tell it, here's an anonymous function, takes A and B, returns A plus B. And this also works. So it's like a one-liner, basically. If you compile it, and we'll get to it in a second, it just works like a normal Python model. In fact, it generates the doc strings and the signature. So you see there's 2 int arguments, returns an int. You give it 1 and 2, you get 3 back. If you give it some non-integers, it tells you that the signature is not compatible, so it does the type checking. So how do you compile it? Well, there's a few ways. If you're a happy owner of a Linux box, then you can just tell it where the includes are, and that's pretty much it. You don't have to link it to Python or anything. So that's literally the entire line to compile it. You can do the same thing on macOS. You just have to add like 1 more flag so it doesn't complain. On Windows, I heard it's possible, but I haven't tried. It's probably not fun. However, there's better ways. So you can actually integrate it in setup tools, distro tools. Just tell it how to find PyBind headers, and that's pretty much it. And you have to tell it that you have to compile it in C++, in C++ 11 or 14 mode. That's it. Then setup tools will take it from there. There's another thing. So I've actually built it specifically for this tool specifically for doing this conference and just for myself, but it turned out to be pretty useful. So that's a Jupyter Notebook extension that you can just load in Jupyter Notebook. And it does all the bootstrapping, and it will compile your model and actually cache it. It will enable C++ syntax highlighting in the Jupyter. It will forward input-output streams from C++. And that's literally the entire cell for this. You hit enter, it compiles it, it imports it back, and you can just use your functions from it. So this one is not released on PyPy yet, but I hope to do it this weekend so you can find it on GitHub. Finally, if you use CMake, it's just the one line that we provide a CMake interface as well. So you say just create a module myadd with these sources, and that's it. All right, so how do we go about wrapping classes? Because that's what C++ is supposedly all about. And so let's create simple bindings for an HTTP class, response class in Python. And this is sort of something like you would get from requests library in Python, like it's a status and reason and text. So for example, in this class you can create it with just status and reason, or you can also pass the optional text, which defaults to empty string. Or there is a default constructor which just initializes it with 200 and OK, which is the browser response for everything went fine. So this is quite simple, and we want to mirror this like one-to-one in Python. So we have the same API. So first of all, we bind the type itself. So we tell PyBind, hey, here's a type response. Please create a type called response, a string. Because there's no reflection in C++, we have to give it the name, like this, a string. So this registers the type, and after this line, you can use it anywhere in any function signatures. You can return it, you can take it as an argument, you can nest it within other types. So let's bind the constructors. So in Python, in C++, you can have multiple constructors with different signatures, different overloads. In Python, you have only one init. So what we do here is, this is a shortcut for, the PyInit is a shortcut. It's a template to which you give the signature, the input arguments to your overload, and then it creates this overload in Python. So in fact, in Python, all these 3 constructors will be merged into one init, and it will do a runtime dispatch. So obviously, static dispatch is not possible because Python is not compiled, but it will look like one function, and in the docstring, it would say that it has 3 different signatures. Okay. The attributes, you can bind the attributes directly into here. And what it does, it creates descriptors on the Python side. They could be read-only, like get descriptors or get set. So read-write descriptors. So we can bind this directly as well. And in C++, we have stud string and int, and in Python you will have like str type, like Unicode type, or a int as well. you can, if you have a property, so as in C++, a method that doesn't take any arguments. So like here, for example, it's OK property that tells it if your status is not an error. You can bind it as a property in Python read-only, or you can actually bind read-write properties as well with a getter and setter. And you can overload operators. So like in C++, there's an equals operator that checks that all the fields are the same. You can do exactly the same thing in Python. So you define the double under EQ, takes a self and the other, and returns self equals other. And because it's such a common pattern, there's actually a shortcut. So you can just include this pybind operators header and say def by self equals self, where this equals could be any operator. It could be like left shift equals or anything like that. This makes it very easy to bind objects that may have like 20 different operators, like matrix or vector type or something like that. You can define any method. Like so, here we can define a wrapper. So this type has a proper representation, and you do it like you would do in Python. So we just create a string and format it, return it back. Okay, and this is the full binding code. And it's not so much really, so it's comparable to, it's less than the initial implementation. And if you were to do this in Python, it would be kind of the same, and maybe more because Python doesn't have like proper overloads. And you can use it like any normal Python class really. So if you import the type, you have your properties, you have your attributes, you have doc strings for everything. So the operator, the equality operator works, so it all works as expected. Now a few other things on function signatures. So in Python you can have all these like args and default values, star args, keyword arguments. So it's all doable here as well. So first of all, you can name arguments through pyarg. Because C++ doesn't have proper reflection, you need to give it names. You don't have to, but if you want your argument to be called name, like name in this case, you have to tell it that. And now if you look at the doc string, it's actually called name. So that's nice. You can assign to pyarg. So here we have the same function, but it runs like n times, where times is like an optional argument and defaults to 1. And this would work as expected. Then you can call this function with 1 argument or 2, or provide it as a keyword argument. And you can do other things, like you can take any Python object's arguments. You can take a PyList, which is like wrapper but around PyObject. And you can, so here, for example, we count all the strings in the list. And if you were to do this in Python, it would literally look the same, like line to line. So you do like for item in list, if is instance string item, increase n, then return n back. So that looks very close, and it works as expected. You can take star args and keyword arguments as well through like pyargs and pykwargs. So as I've already said, there's function. You can bind multiple C++ functions to a single Python name, and then they would work as overloads. So it will do runtime dispatch on the types. So here we have a function that takes an int or float. And you can pass an int or you can pass a float, and it gets dispatched to 2 different functions. And if you give it something else, it tells you it's an error. So that's pretty handy. There's a bunch of other things that I would just like to quickly jump through. So there's 3 ways to communicate objects between C++ and Python. So the first one is you created something in C++, you wrap it in PyObject, and then send it off to Python. And you just sort of store the pointer inside PyObject, and then we record it in like registered instance map. So if it ever comes back to C++, we know that we were the ones who created it. We quickly unwrap it, and it's very fast. Another one is the opposite, where it's native in Python, but it's wrapper in C++. So it's like PyList, PyDict, PyInt, PyString, and it's on C++ side we have a thin wrapper around PyObject that way around. And the third one is like in the examples that I've just shown, so you have stud string in C++ and str in Python. Now these, even in int really, because in Python int is in objects as well, they have different memory layouts, so you can't really share them. So this would always involve a copy. But there's ways to tell it, to work around that if you need to share a vector or a map, for example. So some of the types that we support that have like built-in converters are like scalars, strings, tuples, sequences, maps, dicts, sets, polymorphic functions, like datetime functions. The newer types from C++ 14, C++ 17, like std optional, std variant. You can also write your own typecasters. It's fairly easy, so you can write for example, like a timestamp type that would work as an int in C++, but once you send it to Python, it works as pandas timestamp, for example. So that could be quite handy. A few more things on classes. I will not go into this in detail because it will involve quite a lot of code, but you can do single, multiple inheritance. You can override C++ virtual methods from Python, and it would work, which requires like a middleware class to do that. You can have custom constructors, so you're not limited to this PyInit shortcut. You can do anything there, just like in Python. You can define implicit conversions. So if the types are convertible implicitly to each other in C++, you can make it so in Python it works the same way. So the function that expects a instance of one type can also take another. Okay. You can overload operators, and you can also define static methods, properties, attributes, and all of that. So there's also the Python interface, so it's like everything that starts with, py : like a PyList or PyDict. And we try to wrap quite a lot of it. So it starts with an PyObject, which is the highest level object in the hierarchy, and PyHandle, so it could be with or without ref counting. There's all built-in types like PyModule and function and list and int. You can cast things back and forth from C++ and Python using this cast operator or cast method. You can call Python functions through just using parentheses normally. And I think this is a pretty cool example where we have a tuple of args, and then we have two dicts and a function called like engage. And then we call that and we expand both tuple and two dicts, and we actually pass one other keyword argument, exactly like you would do in Python, sort of. And this is still C++, it's just heavily overloaded. It looks pretty cool, I think. You can import modules. There's a bunch of built-ins that have been wraps like print and format and length is instance and all of that. You can run arbitrary Python code as a string if you want to do that. In fact, we have to resort to doing that on PyPy to make a few things compatible because if they don't have an equivalent for some CPython call, we have to do that. You can evaluate Python files as well. One of the big parts is support for buffer protocol in Python, so you can interact with numeric code. So you can wrap any type, any of custom types, to support the buffer protocol, and then you can for example, NumPy would automatically pick it up. Like you can just pass it into a NumPy array constructor, and it will know what to do. You can build buffers and memory views directly. We also support NumPy. So if you have NumPy installed, you have to include a pybind NumPy header, but you don't have to go and start locating NumPy itself. So we'll figure it out. And there's a few types like PyArray, which is untyped array, and PyArrayT, which is a template around for a typed array. There's things there's a lot of functionality, but the few things I'll mention was there would be bounds checked and bounds unchecked element access, and you have fast access to array properties like shape, number, dimensions, dtype, all of that we do through NumPy C API. There's support for registering structured NumPy dtypes, and if you've never heard what that is, it's kind of like pandas, but in NumPy, like pandas data frames, but in NumPy. And that was my own contribution to PyBind. There's automatic function vectorization and broadcasting, so you can write scalar functions and then just wrap them so they work on any NumPy arrays of any shapes, and that's pretty handy. We also support eigen, if you know what that is. That's it's a numeric C++ library that's quite popular in some scientific circles. And a few other things that don't fit anywhere else, and like different return value policies, so you can tell. So for example, if you're returning a reference or a pointer, you can tell PyBind that it's actually pointed to an internal member, so it knows how to create weak references and garbage collect it. You can also ask PyBind to keep one object alive while another is alive. So like if you're iterating over a C++ container and you don't want it to die before you're done. So that kind of thing. There's automatic translation of C++ exceptions to Python exceptions, you can also register your own translators, sort of like you can do in Boost Python. You can have custom holder types, and we support the default smart pointers like unique pointer and shared pointer. And one last thing I wanted to mention here would be that PyBind does have a runtime of sorts, but it's pretty fast. So the way it works, it has a capsule, so that's like a CPython term for a block of shared memory like within the interpreter. So when you import a PyBind module, it looks for an existing capsule, PyBind capsule, and if it doesn't exist, it creates one. And then as you import other PyBind modules, they look for the same capsule and then sort of find it, and they share the same map of registered types and registered instances. So that's kind of how it works. And the last two sections, I wanted to be like, show a few examples of what you can do, what's possible with this. And one is on callback. So how do you, that's quite common thing to do. So you have, for example, you have a fast WebSockets library in C++, and it takes, like on events, you can pass it a polymorphic function that would be called each time a message arrives, for example. And how do you wrap this in Python? Well, the answer is you can use the polymorphic function type, the std function in C++, and it will be converted back and forth to a Python function object. And this is quite cool because Python function may be actually a closure that has a scope captured, and C++ function can be a closure that has other C++ stuff captured as well. And it works nicely together. So for example, here we have a function for even, so you give it an integer, and you give it a function that takes an int, returns nothing, that would be called for each even number, from 0 up to n. And you can use it like so. So you have like a Python callback. So if you compile that, you have a Python callback that just prints the number, and you just pass that directly in, and that seems to work. You can also do this kind of stuff. You can have a higher order function. So you can make use of capturing closures in C++. So for example, here's so intfn is a function that takes an int, returns an int. So apply n is a function that takes a function and also a number n, and applies this function n times. Although it does it lazily, so it returns you a function that does that, if that makes sense. So it's kind of like a decorator of sorts in Python. So like if f is multiplied by 2 and n is equal to 10, it will be like multiplied by 1024. Okay, and you can note that in the square brackets we have like f and n. So this is a C++11 notation for we capture f and we capture n by value. So this is stored in the closure. And that's pretty much it. Like you can, if you compile this, we can define a Python function and then pass it there. What's returned back to us is a C++ closure, which is converted to a Python function that we can call, and it still works like a decorator. You can actually go one step further. So, so the green one, the green apply n is the one from the previous example, and the blue one is a factor that creates the green one for a given n. So it's like if you give me n, I will give you a decorator that decorates all these functions in such way, if that makes sense. And you can, and just for the fun of it, we can bind it under the same name because we have overloads in C++. So we have two different versions of apply n. One takes an int and is like a factory function, and another one takes an int and a function and returns a function. And we can use them both at the same time. So this is the first example where we have a function. We say apply n of f and 8 of 10, and that gives us 2560. Or we can use it as decorator. So we say, at apply n of 8. So that's a factory returns as a decorator. We decorate a function, and it works the same way as well. So I think that's pretty cool. That's quite a lot of machinery going on here, and I'm quite baffled myself that it actually works. And last but not least, there's like NumPy support was very important for myself, and as I talked to Wenzel, the original author of PyBind, just a few days back. He said that this talk is not hipster enough if there's no pandas and data frames in NumPy, so I figured I should provide one example. So here's a full example. It took me maybe 10 or 15 minutes to cook it up. Here we we want to compute rolling stats on a data frame, or on a series basically of floats. So you have a rolling window that, if you don't know what that is, you have a fixed window size that just moves along through the series. And every time it moves, moves by one element. You recompute some statistic like mean or median or variance, standard deviation. So here we'll just compute mean and standard deviation. And the type would be double, right? So we have this rolling stats function. It takes a pi array t of double. So it would be like a float 64 numpy array. And it takes a window. And what we do next, we just, we use to make it faster, we don't actually recompute it each time the buffer moves. We don't recompute it in full. We can make use of the fact that to compute the mean, every time if you have the sum of elements in the buffer and you have sum of squares, then you can infer actually both the mean and the standard deviation. And to keep track of the sum and the sum of squares, you can just add one element and subtract one element at a time each time you move through the buffer. And it makes it a lot faster than actually trying to reevaluate the whole thing every time. I'm not entirely sure what pandas does so I haven't looked in this rolling API, but it's a little bit slower. And so as you can see from the code, it's not overly involved, and it's, it uses this unchecked proxy access to numpy arrays. So we disable the bounds checking because we know we're not gonna, run over outside the bounds. The rest is just like normal numeric code. We do some computations stored in the stats array. One thing to note is that stats is a struct here, and what we return back from this function is a pi array of a structured type. So this is known as record array in NumPy, or structured array. And in our module, we have to register it explicitly. So we say, hey, here's the stats type. It has stats numpy ID type, and it has two columns, mean and std. And they will be translated to Python with these names. And then we just bind the function. So the way this works, if we compile this and try it out, we can pass anything convertible to a numpy array, really, to this function. So this rolling stats. So here I pass a bunch of ints and window of 2, and you get back a data frame that looks like this. So obviously this is running mean, this is the running standard deviation. So if you were to use the pandas rolling.mean or rolling.std, you would get the same result. In fact, let's check it. Let's just generate 25 million values and do it both ways, and yeah, we can check it that it's the same. And we can also check if it's fast enough. So if you run this in pandas for 25 million elements with window size of 1,000, it takes 1.1 seconds to compute the mean, and it takes another 1.18 to compute the standard deviation. In our case, it takes 0.26 seconds to compute both. So it actually does make sense. And if it starts taking minutes or sometimes hours to compute this kind of things, if you have a lot of data, so it may be worthwhile to spend 10 minutes and code it up yourself. And finally, I'd like to say thanks to Wenzel Jacob, who's the original author of this project, and Jason and Dean, who are currently maintaining it and handling all the issues, adding a lot of features, and a lot of people, including myself, for contributing all the other stuff. Also Dave Abrahams for creating Boost Python and Boost MPL. And I'd like to thank my work employer, Susquehanna, for letting me hack on this at work time. And last but not least, I'd like to thank you for listening. Thanks.
Okay, we have some time for questions if there are any.
Hi, thanks for your talk. Could I pickle class?
Yeah, there's pickling support as well.
Thank you.
I just didn't mention all the features because it will take too long.
Thank you.
Yes.
Hi, thanks for the talk. It looks great. I'm just wondering if you can, if you're always using the heap for allocation, or if you can do any fancy allocation, say placement, or if you're dealing with an array, are you always allocating objects on the heap? heap, or can you do different forms of allocation?
So the heap allocation for what exactly?
So say, for example, when you declare a class, and you have the example of multiple init types, signatures, when you actually instantiate that object in Python,
Yeah.
is it always happening on the heap, or can you do anything different?
Yeah, it currently happens on the heap, so it uses the new operator in C++. But I think, do you mean like the new Python malloc, PyMalloc API? So we don't explicitly support that, but it should be possible. Yeah, thanks.
The library looks really, really cool. I'm wondering what the state of documentation examples and what's the license of the library?
The documentation is pretty good. It's pretty well maintained, I would say. It explains a lot more than this talk, and it walks you through the examples from from the really simple ones to the most complicated ones. So it's what we're also planning to do is set up a tutorial notebooks that will, so you can run the whole thing in Jupyter Notebook as well. But the documentation is hosted on Read the Docs, so you can find it on our GitHub repo. We also, one thing to note is that there's a few things in this talk, there's a few syntax differences in this talk from the latest stable release. So it's actually, if you try to compile this with the whatever's on PyPy right now, it may complain, but we'll push a version fairly soon that will, be compatible with this.
And what's the license of the library?
Hmm?
The license, is it GPL, is it MIT, is it?
I think it's MIT.
You mentioned that the problems with Boost Python are the long compile times and the generated shared object size. So do you have any numbers on how PyBind compares to that?
I'm sorry, numbers on what exactly?
So the compile times?
Compile times, yeah.
And the generated code size.
Yeah, so the thing is, if you have a really small module, then the extension model generated with Boost Python would be smaller because Boost Python has a compiled part, like a pre-compiled part, right? So PyBind model would actually be bigger than both Scythe and Boost Python if you have like a two-liner. Once it starts going up, so as I said, we have an example of it's a PyRosetta wrapper for a chemical framework that was initially written in Boost Python, and then the developers tried to convert it to PyBind, which they did successfully. And I think it went down by a factor of like 5.8 and 5.7 or something like this, both compile time and the binary size. And in my experience as well, so I don't personally use Boost Python, but I did some benchmarks just to see that it's true.
So I assume the global interpreter lock is held when C++ code is called from Python, and can I drop the GAL?
Yeah. Again, I skipped it here just for the sake of time, but you can. There's things like scoped. You can have like a scoped guards for GAL release, for example. Yeah, that's all there as well.
Any other questions? Okay, great. Well, thanks again.
Thanks a lot. Should plug this out. Hello. Thank you.
Okay.
For our last session in here before lunch, we have Mark Smith, and he's going to be talking to us about Python and refactoring. So give him a warm welcome, please.
Hello, everybody. Thanks very much for coming. I know the social event was pretty successful, so I'm even more glad that you made it. I will try not to shout too much during the talk. So before I go through the topic of this talk, first I'd like to talk about something more important. So my name is Mark Smith. I'm a developer advocate at Nexmo. I run the user group for Python in Edinburgh. My handle on most social networks is Judy2K for reasons that aren't as funny as you might think. I am known for writing silly Python code and then showing it to people for my own amusement. And despite the Viking helmet that I kind of use as my general brand, I'm not a Viking or Norwegian or Scandinavian in any way. So talking about Nexmo, briefly, we're a sponsor of the conference. You've probably maybe spoken to me on the booth. If not, and you would like to, come and talk to me some point later today. We've got REST APIs for sending and receiving SMS messages and making phone calls. Can I just do a quick show of hands? We generally do this because not many people have heard of us usually. So before this conference, who had heard of Nexmo? Yeah, it's getting better. So my job at Nexmo is to maintain our client libraries for Python and Java, and in my own time, I maintain a library for Go. And so I think a lot about compatibility and maintaining compatibility, and just kind of my job is really to communicate with developers and find out what they want and try and feed that back into our product pipeline. So this talk really ended up not quite being about refactoring. It's related, but it's not quite about refactoring. If you do want to know more about refactoring, I highly recommend this book. It's been around for a while. I think it popularized the concept generally. It contains 72 refactoring recipes for kind of modifying your code in order to improve the quality of the structure and the architecture of the code. It's very Java-centric, but it's got lots of experience in the pages of the book. It's got lots of good advice, but some of the patterns also don't really transfer to Python. I mean, Java is a very different language to Python. But the main theme of the book is to be prepared all the time to be modifying your code to keep it clean and to allow new architectures to emerge as you kind of discover them through developing and extending the library. What the library's not really worried about is whether you break your user's code. It doesn't worry so much about interfaces, it's more worried about kind of code that is kind of, you're allowed to change at any time. Now, this isn't really true of libraries. This talk is really about Python library maintenance, and it's got this assumption that you have released code with 2 or more users, and so what that results in is you've got a one-to-many relationship. So if you break backwards compatibility in your one code base, your users, in order to upgrade, are going to have to change their code, and that's going to be many changes. So that's something that should be avoided. So the other part of this talk is about hiding change from your users. So it allows you to change things internally without affecting your users in 2 negative ways. So what we're really talking about is keeping our interface stable while changing the code. So the reasons you'd want a stable interface, I mean, I think they're pretty obvious, but I'll go through them anyway, is really to keep your customers happy, to keep your users happy. Every time, if you keep breaking backwards compatibility, they're going to get unhappy in general because you're making more work for them. Nobody likes being given work that they didn't necessarily want. And also, every time you break backwards compatibility, you're giving your users an opportunity to switch to a competing product, competing open source library. So if they're going to have to rewrite their code in order to keep on using your library, why not just switch to the new hot thing? And this has happened in web frameworks certainly a long time ago. Frameworks which I don't really want to name because I feel like I'm maybe demonizing them a little bit, but there was a big glut of frameworks about 15 years ago, and nobody was really sure what the right way to do things were, and as they learned, often they broke backwards compatibility. And really what ended up, the successful frameworks, the ones that we're still using today, were really the ones that worried a lot about maintaining backwards compatibility with their users. So really, libraries only survive if they're stable, and that's why we want stable interfaces. So we talk about this idea of an interface, whoops. What is an interface? I think of it as the boundary of your code. So it's the code that your user interfaces with. So it's where your user uses your code. And if you change it, it's where your user will be affected. And it consists of various components. So the obvious one is a module. They'll be importing your module or package. So if you change the name of that, that's going to break things. The thing we usually think about is that the module consists of classes and functions and methods, and that's our interface, our agreement with the user. To go slightly finer grained, we've got the parameters that our functions and methods call. If you change the names, the expected types, return values as well, this is going to affect your user in negative ways. We've got global variables that are usually static, but potentially you might want to change them with something dynamic, and that may cause problems. Something that people often don't think about up front is exceptions. So if you change the names of your exceptions or the hierarchy of your exceptions, that's going to cause problems for your users. We've got the structure of our code. So this is really kind of where your code lives. If you start off with a big single namespace and you've got a kind of utility function in there, your user might find it, decide it's useful, start using it, and then if you decide to tuck it away in a utils package, sub-package later on, that's going to break your client's code, but it's not something you necessarily expected. And finally, this is a little bit of a silly example, but we've got bytecode as well. So potentially even changing your bytecode could cause problems for your users. So I don't know if people saw Sebastian Noack's go-to hack at the Lightning Talks a couple of days ago, but he's got a decorator that decompiles a function and modifies the bytecode and recompiles it again in order to allow you to use go-tos in the code. So potentially changing the structure of your code might also break your compatibility with your users. This isn't really something you have to worry about because really they've broken all the rules if they do that kind of thing. But this is really kind of the bigger topic of the talk is making an agreement with your customer. So ideally, interfaces, your deal with your customer is as strict as possible. I think of it as kind of one of these kids' toys. So you've got the idea of well-defined objects passing through the wall of the interface. They're validated on the way in. You may call functions and methods with these objects, and then ultimately well-defined, stable, well-understood objects are passed back or exceptions are raised. In the ideal world, it's impossible to refer to classes, methods, functions, or variables that aren't exposed by the interface. A couple of days ago in Hinnick's talk, he used the analogy of ravioli, which I think is particularly appropriate given where we are, and the idea that your interface is like the pasta that keeps the filling of your ravioli separate from the tasty, tasty sauce. It stops your dish from just being a mess. But the concept here, really the idea, is that even if you're not publishing your library, even if you don't have external customers, your code should be divided up this way. It's much easier to understand like small, well-contained code libraries. So talking about strict interfaces, here are some things that are like that definition of a strict interface, like the toy. And there'll be a few sniggers, I suspect, looking at this list of technologies, because none of these are technologies, apart from maybe the first one, that we particularly enjoy working with. They're all a little bit painful. If you want to define interfaces with J2EE, you essentially define your client code, your server code, and a third module that's shared between the two that is your well-understood interface. With SOAP, you define a WSDL file, which defines, again, incoming and outgoing objects. So you're defining your interface separate from your implementation. And these ideas have been around for a long time. The dates on there are kind of 17 or 18 years ago. But it goes back to Corba as well, which is a hideous technology. It's enormous and horrible to deal with, but that's 26 years old. So these are things that are like getting towards our ideal world. Python isn't like that. Let's have a look at a quick example. So this is a bit silly, but I've imported requests. And I'm just listing the stuff that's inside the requests library. I'm sure we've all used it at some point. We've got a magic thing that begins and ends with a double underscore. We've got a private thing that starts with a single underscore. We've got some things with interesting names like get, which is a function, compat, which is a submodule, and models. And it's not immediately obvious with some of these whether they're private or public, whether we're really supposed to be using them. And something stupid we can do with it is we can import the module, we can then define a function, and then we can modify the request module that we've imported with our own get function. And then anywhere else in our code base where somebody imports requests, so they get our modified requests, and when they call get, it doesn't make an HTTP request, it just prints out a silly message. But it gives the idea, you can dig as deep as you want into somebody else's Python code and switch out things that they may not want you to. And so we've gone from another appropriate seaside analogy. We've gone from the idea of our library as having a kind of tough shell that's difficult to break through, that only gives you access to things on its terms, to what Python is, which is really just kind of a box of Lego. You can reach in, you can grab anything you want, you can take it apart, you can put it together in different ways, and then put it back in the box. So what we really need to do is kind of build our own. Thank you. So we need to work with the tools that we have in order to build an agreement with our users. So we need to make our interface knowable, because we can't stop people from digging into our code, so we have to make sure they understand what we expect from them. And how do we do that? We've got a few conventions, so here I've got a private method. We know it's private because it begins with a single underscore. The single underscore doesn't change the behavior of the method at all. We can still call it. You can see the last line of code. I call it, it works. But we know just by reading the name of the method that it is considered to be an internal detail, that we're not really supposed to call it from outside this code base. So we should be using these. This is something that you kind of get for free, an agreement with your customer that this is a private implementation detail. What you sometimes see in less experienced developers' code is that they've read a book, they've discovered that there's this double underscore prefix, and then they start to use that for private methods especially. And that isn't what this was designed for. This was designed to avoid namespace conflicts. So this does change the behavior of the class. The method name internally is changed, and it's just prefixed with the name of the class and a single underscore. So you can still call it. You haven't stopped people from calling it, you've just made it a little bit more difficult. And ultimately, if your user really wants to call that method, they're going to call it anyway. Although, by this point, they've probably copied and pasted the code into their own code base, so it's a different kind of problem. And a third convention we have in the Python world is just to kind of move the code out of the way. So often you'll find in some quite popular libraries, there's a public module or package at the top, and then there's a sub-module internally that really contains all the code. And then in the public module, that is the thing that the user is expected to import, they've just kind of imported the public interfaces, the public functions and classes from the private submodule. So it just puts it out of the way. If somebody imports your public module and then does a dir, everything they see is something that they're expected to work with, and that's good. So I recommend that too. But these are kind of, you get these for free. These are conventions in the Python world. Something a little bit more expensive, but infinitely valuable, is documentation. Documentation is the primary way that you communicate with your users. And the Python ecosystem has excellent documentation, so much so that it's spawned a series of international conferences dedicated to documentation, the Read the Docs conferences, that I would say spun largely out of the Python community. And the reason documentation is so popular in the Python world is that we've learned that users will use the interface that you document. We usually distribute source code, as our libraries as source code, so somebody can read the code, but you don't really want to. If you don't write documentation, users will read your code. If you don't write documentation, users will guess your interface, and they'll get it wrong, which is not something that you want. So for documentation, I recommend Sphinx or MakeDocs. MakeDocs is supposed to have a capital D. Dougal, the maintainer of MakeDocs, is sitting in front of me and has warned me about this before. I don't recommend auto-generating your documentation. It's a really bad idea. By default, everything is going to be published as documentation. That's not what you want. You want to filter your documentation down to the things that you want your customers to use. Slightly related to this is type hints. So, I mean, it's a recent addition to the language. I think it's still pretty controversial. Doesn't change the behavior of the code at runtime by default, but it is used by IDEs to help users use the right types, ingoing types into your functions, and return types as well. It gives the user an idea of what they're working with. So in general, I think they're a good idea. Whether they're worth the cost of maintenance is difficult to tell, but I'm trying it out in the Nexmo Python library to kind of see whether that's something we want to expand and take forwards. But once again, we're sharing an understanding with our users, which is a good thing. So in answer to our original question, what is our interface? The answer really is code that's documented. Because that really is what the users will see. It gives them no reason then to dig into your code, get confused about what they're supposed to work with. And so this is a good place to be. So once we've created an agreement with our users, then how do we stop ourselves from breaking the promises that we've made? And the answer is testing. So there's this famous quote, which although I've attributed it to Jacob Kaplan-Moss, he denies ever having said it. So really it's kind of, it should say anonymous at the bottom there. So I would say there's a corollary to this, which is that if you're not testing your interface definition, then you don't have an interface definition. And to look at this standard testing pyramid, the idea here is that at the bottom we've got unit tests. We want as many of those as possible, or we want more of those proportionally, because they're quick to run, they're cheap to write, they're easy to maintain. And then at the top you've got manual tests, which are heavy and slow, and you don't want to do those. So in the middle somewhere, I would say you want fewer than integration tests, but you definitely want to have your interface tests divided out. That means that when you find yourself changing your interface tests, you know you've changed your interface, which means then you need to work out what you're going to do later on. You need to communicate these changes to your users. And the way you communicate changes to your users is through versioning. I recommend semantic versioning. So that the thing here is that your major number, which is the first number in this, I mean, we've all seen this, but the major number indicates backwards compatibility. So whenever you break backwards compatibility, that first number changes, and your users then know that this is going to cost them some effort to upgrade. Minor and patch numbers are less aggressive changes and usually won't change the compatibility with the user. This is documented in detail on semver.org, and they're on version 2.0.0 of the specification, so they're eating their own dog food. Along with versioning, we've got release notes. I recommend you check out keepachangelog.com. They offer guidelines for maintaining your release notes. They say that every release you should divide your changes into a list of the things that were added, changed, deprecated, removed, fixed, or are security changes. So the two that we're really interested in here are changed or removed. Those are things that are changing backwards compatibility, so the things that we really, really need to make sure our users know, because it's going to break their code. So although we're talking a lot about not breaking code, it is okay to break backwards compatibility, but you want to do it occasionally. I recommend keeping a branch of breaking changes and pushing them, unless they're essential, pushing them kind of in a block so that you're not drip feeding changes to your users. That's a pretty negative thing to do. And in general, add new functionality alongside the existing functionality and deprecate the existing functionality. So you're letting users know that they should be migrating their code. Have a deprecation policy. I quite like Django's deprecation policy. Anything that they mark as deprecated gets removed, apart from a couple of caveats, gets removed in the next major release. But you could leave it 2 releases, so it gives the user more time to kind of adjust to the changes that they need to make. So the real theme of this so far is that good engineering practices protect your users from changing your library. So documentation, testing, and versioning are things you should do. So I'm going to skim through some technical solutions now. The last time I ran this talk, it ran over 40 minutes, so I'm really going to be giving you some ideas. But I'll give you a link at the end of the talk, which links to some code that demonstrates all the examples that I'm about to give. So the first one is pretty common. I suspect everybody in the room's used it at some point or not. You've got a class with a static attribute, so it's pre-generated, and you want to change it to a dynamically generated value. And the way to do this is to use the @property decorator, which just makes something look like it's a static attribute lookup, but in fact calls a function instead, so you can generate the value at that point. So you can have it generated based on network value or time, or calculated from other values inside the class. So that's pretty straightforward, but it's a good example of one of the things you can do in Python that you can't do in many other languages. And the way that works is down to something that you can read about in the Python documentation called the descriptor protocol, which I highly recommend. It gave me a real understanding of what's going on beneath the surface of classes and attribute lookup. So the next kind of refactoring thing you might want to do is to change the way that classes are instantiated. So this might be so that you only ever have one instance of a class, so essentially a singleton, or so that you have a factory. So objects that may be expensive to produce are pooled when they're not in use, and then you return something from the pool if there's one available, or you generate a new one on demand if there's not one available. Or possibly block until one's put back in the cache. So in the refactoring book, this is actually called replace constructor with factory method. But the nice thing about Python is we don't need to do that. So we can implement the lesser used dunder new method. And then inside there, we can either return a new class by calling new on the superclass, or we can look something up and just return that value. There's no kind of prerequisite that you have to create a new class when you call a constructor, which is kind of neat. So we can make these changes transparently to the user. They don't know that you've switched from instantiating each time to returning stuff from a pool. You've done that under the hood, which is good. The third example is replacing functions with methods. So when I start a new module design, I tend to start with functions. I prefer those to classes generally, but sometimes what you find is you end up with some global state in your module, which then if you change in the module, it's essentially a singleton value, and so you can't have multiply configured modules. So really the way that you do that is to define a class inside your module and then instantiate that for the different cases that you have. So if you've published your library already with these top-level functions, that's kind of a problem. But we can get around this because Python's got some pretty cool features. So this is the end result of this. So the idea is that you had a module with the do the thing top-level function, and what we want to do is put it inside a class. So to start with, we've created our class, we've taken the top-level function, and we've moved it under the app class. So this is great. We can now instantiate an app, and we can call the method. But this is broken backwards compatibility, so we need to fix that. And the way that we fix that is we create a default instance of our class. We can either make that a public thing or a private thing. I think it's quite nice to make it public so that people can start to use module.default to refer to it. And then what we do is the bit of magic, where we take the method, which can just be assigned to a variable. So that's what we've done. We've assigned it to the global variable, do the thing, and now it looks like a function. It's not a function, it's a bound method on your instance, and it's just quite a nice way. You would do this with each one of your top-level functions that you've put inside the class. And finally, and this is a slightly silly example, but it's neat, and again, it shows it shows how flexible Python is with being able to switch out certain types with other types when necessary. So in this case, I have a module which I really want to replace with an object. So this is the module, and it's got a single global variable in there called salt, and you can see it's static, it's number 4, but somebody comes to us and tells us, actually that shouldn't be 4, that should be generated, that should be the result of time. So that's awkward, because people are already using our module, and they're calling module.salt to get it, or in this case important.salt, to get access to that value, and you need to generate it dynamically. So you really want to replace that with a function, but you can't do that, because that breaks your interface with your user. And if it was inside a class, you could use the property decorator, but you can't do that because they don't work on top-level functions. They only work inside classes. And so what we need to do is replace the module with an object instance. So this is like crazy stuff. You probably don't want to do this in your code, but I just wanted to kind of show how you might do this. So here we've got a class called fake module because it's going to pretend to be a module. And then we've defined our property on it. So we can, if we had an instance of this, we can refer to the instance.salt and get back our value as if it was an attribute rather than a function. And then here we instantiate our silly object, and then we assign it to the module. So every module you've loaded inside your application is put into this dictionary in sys.modules. You can have a list. You can list it at any time you want to and see the modules that have been loaded. But like many things in Python, it's mutable. So you can replace the module that's been loaded with an instance. So now, anywhere in the code that refers to this, oops, I don't actually have a slide for this, excuse me. So anything that refers to that code will continue to work, but it will get back a dynamic value from this point on. So just to run through some further techniques, really what this comes down to is understanding the Python execution model. And there's various of these magic methods and variables inside Python that you can use to replace one thing for another, to essentially objects pretending to be other types of objects. So we've already seen using dunder_new to change the construction of a class. We can make objects behave like iterators behind the scenes. This is how iterators and iterables work. We can make method calls look like attribute access using dunder_get. This is what property uses behind the scenes. We can make classes that act like functions by implementing dunder_call. So you could replace global state with essentially an instance that's callable, which is kind of neat. So, and then there's manually extracting parameters. So we can be extremely flexible about how we extract parameters inside a function. So obviously normally you list the functions that you want. Sometimes you have an asterisk args to kind of collect random stuff that people might send into your function if you're particularly flexible. But he's just shown me a number and now it's distracted me. It's completely thrown me off. But we can be much more flexible about that. We can kind of define the rules of what's accepted within inside a function and kind of almost deal with different sets of parameters that are provided. So if you were to look at the low-level documentation for Flask, for example, almost everything in there takes asterisk args or asterisk kw args, and then it just kind of pulls out the values that it needs to make the call behind the scenes. And if you don't provide the right set, you'll get an exception of some kind to tell you that you didn't follow the rules that have been defined in the documentation. Many of these special methods are described in Dive Into Python, which is free and available online. And yeah, I highly recommend having a look through the list to see what's possible. When you're using these tricks, especially the last trick, you have to be aware that every change you make has risks attached to it. And the more magic you use, the more risk you're really taking that you're going to break compatibility accidentally with your users. So just be aware. Sometimes often it's better to break code than to use magic. So yeah, I would say generally default to the straightforward changes, but if you have a lot of users, that might stop you from making changes at all. So just be aware that there are opportunities sometimes to use a little bit of magic to help you in your relationship with your users. The use of exceptions in code varies wildly between different code bases, so it's very difficult to know what your user is going to do in their code base to handle the exceptions that you throw. So I don't really have any advice for this, it's just that be aware that any changes you make to the set of exceptions that you throw may cause problems for your users. It's another issue for documentation. Make sure you document clearly what the exception conditions are and what will happen in those cases. Type assumptions, because it's a dynamically typed language, are slightly scary in Python. So when you switch out one type for a supposedly compatible type, so you change a string for a list of characters, or you change a string for an iterable of characters or something like that, they often look compatible and your tests might continue to pass, but suddenly you can't loop more than once because you're dealing with an iterator rather than a data type that you can loop through multiple times. So just be aware that these do have different properties and make sure that either your documentation changes to match that, or that you don't make the change at all, really. Monkey patching is always a risk. People do crazy stuff, especially if you find a bug in your code that you don't respond to quickly enough. They will inject their code into your code base. There's not really anything you can do about this. They've broken the deal with you. So it's not something to worry about, but it's just something to be aware of. It will happen. There's no silver bullet. You will break client code. I mean, Python is such a dynamic language and so open and transparent that any change you make carries some risk. But ultimately, it's a question of documenting to your users what the assumptions are and trying as much as possible to keep to that agreement. So to sum up, if you want your interface to be strong and stable, you need to know what it is, you need to document it so your users know what it is, you need to test it so that you're keeping the promises that you've made. When you need to change backwards compatibility, you need to communicate that with your users, and it's better to do that up front than after the fact. And it's helpful to know some tricks for swapping out code in a dynamic language like Python. So there's a GitHub repository on that bit.ly address, which contains more low-level details of some of the tricks that I was showing, and the PDF of these slides, if you're interested. You can contact me on that email address, or feel free to follow me on Twitter. And if you see me around the conference, I'm usually wearing a pink hat. Feel free to talk to me about Nexmo or this talk or anything else. Thank you very much.
Okay, so I know Mark is not taking questions, but track him down because it's now lunch, and do ask him about refactoring, and also make sure you ask him about the upcoming Python Scotland conference that he's organising. Thanks again, Mark.
Good.
Hey, so our next session will be an interactive session. Please welcome Emma, and she'll explain what we're doing today in just a bit. Please make her feel welcome.
Cool, thanks for coming. I hope this should be quite a fun interactive session, so I hope you've picked wisely. So just briefly, I'm Emma. I'm a Python developer at Cambridge Medical Robotics. We're a startup working on next generation robotics for keyhole surgery. It's pretty cool, and we are hiring, so if you're interested, I'll put a link up at the end, and you can come talk to me. So on to the session then. What on earth is Python B? So this was created in 2008. A group of MIT students entered it into a competition for bad ideas, which it won and has suitably been run ever since. It is utterly ridiculous. It's great fun. So if you've heard of a spelling bee, where you have to spell words out loud, so this is like that for programs. So you have to spell like a single character at a time, your solution out loud. Yep, even the white space, even the punctuation, absolutely everything. You're not allowed to look at the code whilst you're doing this. So someone else will be typing it in for you. So the white space one, you're probably immediately wondering, tabs or spaces. We may get to several levels of indentation. I don't want anyone to have to sit there and remember if they said 12 or 11 spaces. So flame wars aside, tabs, just make our life easier. So we'll set our editors such that a tab is 4 spaces and just avoid that conundrum. So how does this ridiculous thing work? We are going to give you an example. So I've set up a load of files. Each of these has the module doc string, contains what the problem is that you're supposed to do. Then there are some tests, and the idea is you write some code and the tests pass. So in this case, somebody would read out the question to you. So they would say, write a function f, which takes arbitrary input, yet always returns hello world. So obviously they'd need to say out loud the capitalization of that, because you can't see it. And then you would go about writing your solution. We have this thing here. So whoever's typing in for you will delete this, and then you'll say your solution. So I'm not allowed to look at that. Okay, so DEF space F open parentheses star A comma space star K close parentheses colon new line tab RETURN space single quote H backspace capital H ELLO space capital W ORLD quote run test. Okay. And then someone will have typed that into for you. So you'll notice that most editors are going to put extra stuff in for you here, so you need to be really careful. If you can use a plain text editor, just like Notepad or something, that would be great. If not, make sure if you're typing stuff in, you're deleting any extra characters. So again, you'll probably have auto-indentation, so either set your editor so that isn't happening, or just delete it for them. And as I said, either set it so that tabs are 4 spaces, or just type space 4 times if you really can't bring yourself to use tabs. Right, so we now run these tests. That was correct, so it'll return silently if everything worked. If, say, you'd, I don't know, got enthusiastic and put an exclamation mark in there, you'll have some test failures. All right, so that's going to be the idea. How are we going to set this up? So actually some hints. So as I said, you can say backspace if you make a mistake. If you're getting to lots of sort of nesting and you want to track where that's going, I advise, like, your fingers are a useful stack. You can pop back out as you want to track indentation. Parentheses, square brackets, be really clear about what you mean. So it's open and close parentheses, open and close square or curly brackets. Be very clear. Similarly, if you want an uppercase character, you need to say capital, whatever, otherwise they'll assume lowercase. I wouldn't get carried away and worry about elegant solutions and performance here. Just make the code work. Yeah. So scoring. So we're going to have a set of these test files. If it returns silently, it was successful, you get some points. You don't get another go if it fails. The questions are divided up into easy, medium, hard, where hard is, bearing in mind you're not allowed to look at the code, and this is entirely ridiculous rather than hard in any other context. So you get a different number of points, 1, 2, and 3 respectively. Just keep a mental note of your score. We'll try and declare an overall winner at the end. And no peeking at the questions / doing one that you've just seen someone else do. That takes the fun out of it. Just be honest, don't do that. Setup. So we're going to try and groups of about 3. You only need 1 laptop between you. So if you have any setup issues, just put your laptop away and use someone else's that works. The idea is at any one time, 1 person will be having a go and 2 people will be typing. It'd be really annoying if someone just put a typo in and that caused you to not get the right answer, so that's why 2 people watching over. And then about 10 minutes each, and then we'll swap over. The questions are up on GitHub at that link there. As I said, try and use a plain text editor or set things up so that tabs are 4 spaces, auto indentations off, that sort of thing. Agree on your version of Python. I've tested these questions with both 2.7 and 3.6. Over those should be fine. Obviously, you need to know which one it's set to use. And standard Python library only. And yeah, have a go. Get into groups. If anyone's got any questions, put your hand up and I'll come around. Yeah, let's get started. One final comment. You might find the easy questions potentially quite boring. They're there in case there are any people who are really quite new to Python. So probably medium or above if you've been using it a while. Yeah. What's that, sorry? It's got a title and everything.
like you to not record it. Thank you.
We should. Yeah, Nave had the practice one.
You could just pick anything.
It's fine. What Python file did you give yourself? Yeah, this guy's a pep board. I think he gets hard ones.
You were what?
He's written some peps.
Oh, I see. I think you have to use your peps in your solutions.
If one of the questions is publish a package to PyPI, then yes, you can use one of his peps. I can't use any of my peps because we're not using Windows here. So.
Okay. Write a function f which takes positive integer as input and returns true which is perfect or false otherwise. The number is perfect if the sum of its divisors, excluding the number itself.
Let's just show under the dog test.
Itself.
So whatever you read into the microphone so they can record it.
We could get one of the easy ones if probably I didn't even
Get all the details there.
if the factors add up to a number.
I actually can't find the solutions if you want to do something.
Yeah, I mean this is going to be a pretty hard question even if you were typing, I think.
Yeah. Okay.
Unless there's a helper function.
What if you would like to try it?
Unless there's a helper function in there for like
Factorials?
yeah.
So that's not a good one, right?
Factorial.
Calculation. Write a function f which takes a positive integer and returns its factorial. Factorial is n times n minus 1 times and so on back to 1.
I'm not the worst person to do this.
F of 0 is 1.
You see the dot tests again. And it has to be linear time and linear memory.
I think some split the dot tests complete within like 30 seconds or something.
These are the easy ones.
These are the easy ones.
Wow, because I'm really bad at this. So what if you want to try?
I'm happy to.
You're getting close to check this, whichever.
Yeah, okay.
Okay. You want to have a go, Steve?
Yep. Okay, can I have a look at the doc test then? Since now I know I'm going to do it. Yeah, so you can check that you're doing that. Okay. Okay.
You can, in theory, I guess, just like memorize all of those cases, but good luck.
That last case did not look, yeah, I considered a lookup table, but that last case is fairly big. I have a great idea that I'm going to save for a really hard one now.
So time to swap over if you haven't done so yet.
Okay, here we go. DEF space F open paren I close paren colon new line tab IF space I equals 0 colon RETURNE space 1 new line tab, RETURN, space, F, open paren, N, minus 1, close paren, asterisk. I need to go back and change the N's to I's. Left arrow, left arrow, left arrow. Actually, Control A, delete. Just for the function. Just for the navigating around is not going to work. Well, and I'm going to say exactly the same thing, but with I instead of N. So if you just want to fix those up and go back to the asterisk, then that's fine by me. Okay, back to the start. This is recorded now. Okay, DEF space F open paren I close paren colon new line tab RETURN space 1 IF space I equals 0 ELSE space I asterisk F open paren I minus 1 close paren. Happy, all good. So Python 3.5, right? Yes. Haha. So as of Python 2.7, and you are actually getting the syntax error for that? You shouldn't be. There's no syntax error in there. That's fine, they're unambiguous. You don't need spaces between unambiguous tokens. I actually voted to not fix that bug, but in Python 3.4.2, I think, or 3.4.3, someone complained that 0 else should have, was being parsed incorrectly, because it was being parsed as 0e. Oh, L is not a valid exponent, syntax error. And they were saying that 0 else are two unambiguous tokens and you shouldn't have to put a space between them, so we fixed the parser to go back. If we found digit E non-digit, we'd go back and say it's a number followed by E rest of whatever that token is. So yeah, this is what happens when I get easy questions. Now I get a medium one, do I? Just jump straight into the advanced ones. I have my trick. I have another trick. I just want to show off my trick. Nah, I'll give an advanced one a go. My trick was going to be import sys.exit 0. But doctest might be smarter than that. Oh.
Write a function f, which given a positive integer returns the value as a Roman numeral, where in Roman numerals I equals 1, v equals 5, x equals 10, l equals 50, c equals 100, d equals 500. Those are all lowercase. The value you return should use as few characters as possible, e.g. 4 should be IV rather than III.
you can assume that the number you have to convert is less than 1,000. And actually the tests allow you to output the number in either lowercase or uppercase, but it has to be consistent. You can have, oh, it's just gone into standby, so press the button there. Okay, now hold the microphone while I type my password in. Okay, and 3 of something is 3 of so 3 would be I have. Are you ready to code? Are you hanging on the edge of your seat?
Yeah, I guess I should make a start. Let's see how this goes. There's a function f, right? Okay. Okay. def space c open paren I close paren colon new line tab WHILE space I greater than equal to 500 colon enter tab tab I minus equals 500 enter tab tab YIELD space yield Y hang on YEILD is what I said. Might not be what I said. Shift home delete. I hope that works on your keyboard. Cut line tab tab YEILD space single quote D close single quote new line tab IF space I greater than equal to 300 colon new line tab tab IF space I greater than equal to 400 colon new line 400 colon new line tab 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 YEILD space single quote C single quote enter tab 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 plus equals 100, new line, tab, tab, YEILD, space, single quote, C, D, single quote, new line, tab, tab, I minus equals 400, new line, tab, WHILE, space, I greater than 100, backspace, 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 equals 100, colon, new line, tab, tab, I minus equals 50, new line, tab, tab, YEILD, space, single quote, C, single quote, I think I've screwed up here, but whatever. New line. Tab. IF space I greater than equal to 80 colon new line tab tab IF space I greater than equal to 90 colon new line tab 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 YEILD space single quote X single quote I'm totally off now. New line, just forge ahead. I shouldn't be into the tens yet. Tab, tab, tab. I plus equals 10. New line. Tab, tab. YEILD space single quote. Yeah, I know where I've gone wrong now. Okay. Let's just hope there's no test for this. XC, single quote, new line, tab, tab, I minus equals 90.
Okay. It's time to swap over again if you just finish the question you're currently doing.
New line. This must look so good. We should be getting what you're typing on the screen for people who are watching, because this is going to be a really boring video otherwise. Yeah, that's probably a good idea. I think I'm so far wrong with this that I'm not going to get any good score anyway. Okay, let's bail out and just go for successful tests. Tab, WHILE space, I greater than 0 colon space, new line, tab tab, YEILD space, single quote, I single quote, new line, tab tab, I minus equals 1, new line, DEF space F, open paren, I, close paren, colon, new line, tab, RETURNE, space, single quote, full stop, JOIN, open paren, C, open paren, I, close paren, close paren. I gave up. Some of those numbers are going to have a lot of I's in them. Oh, really?
Every time you spell U, you spelled it Y-E-I-L.
Is it Y? It is Y-I-E-L-D? Damn American spellings. What? Did I have an E on the end of? I did not. I did not. We have video proof.
It sounded, well,
R-E-T-U-R-N. There's no way I would have put an E on the end of that. That means space. Yeah. I always do that with Yod as well.
you did get the first test to pass.
Yay! The first test was 1, wasn't it? it went, yeah. Okay. Well, my second plan then is import os.exit 0. But I suspect that doc test is going to catch system exit and report that as a failure.
So if you do os._exit 0, then you bypass system exit entirely.
There you go. All right, must be your turn, Thomas. Let's get it up on the screen so we can actually record the typing.
Can we use your laptop?
No, because you're going to get the microphone.
Are you having a copy of the problem in front of you?
Yeah, he hasn't been looking through all the other ones while you were sitting there, right?
One do you want to do? Put it on here.
What's your PhD in again?
But I'm willing to try medium.
Alright,
Oh, okay. Check out the doc tests.
what medium would you like? Balancing some checking if parentheses are balanced, or?
We got balance parentheses.
Oh, nice.
Yeah, this needs to be earlier than
Not after the social.
yeah.
Alright, you wanna give it a go?
We've got to take that away from you when you start.
Okay.
Okay.
I don't think you do.
You want to?
Someone like to type, and I'll check everyone else's.
Sure. I think we do. It'll distract you, but it's something to look at. You need to be smiling at the camera.
Order matters only count.
You're on camera for this one. You've got to look good. I mean, yeah, you can see what I'm typing. Just let me know if I type something wrong. I might type something wrong because I'm not used to this keyboard layout. But I'm basically hunting and pecking as well, so I'm basically hunting and pecking here as well, so it's not going to matter. Has anyone gotten a score above 0 yet? Everyone has 0. Oh dear. We're just doing one on the video, so don't mind us speaking into the room.
You ready?
Thomas is ready. Go.
DEF space F open parentheses S close parentheses colon.
Okay.
New line, tab, P equals 0, new line, tab, for C in, right, sorry, I have to spell these out. FOR space C space IN space S colon
Right, just 5 minutes, and we're going to do the second half of a different exercise.
new line tab tab IF space C equals single quote open paren single quote colon new line tab 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 P plus equals 1 new line tab tab ELIF space C equals single quote close paren single quote colon new line tab 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 IF space P equals 0 colon new line tab 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 RETURN space capital F ALSE new line tab 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 P minus equals 1 new line tab RETURN space P equals 0 save and run tests.
I don't even know what you're working in here.
Congratulations. Okay, well done. I think that's a good place to stop, so I'm going to go on to the second half. If we can all just stop there where we are, I'll knock out once. So, because that wasn't absurd enough, now we have something completely different. Co-op mode. So, I'm going to write code as a group, so you get to write a single character, and then the next person gets a character. You do get to look at the code now, which is more helpful. You're not allowed to talk to each other, you're not allowed to do any hand signals, no communicating, no complex sequence of winks or anything like that. Absolutely no talking. I suggest you just pass the laptop round and enter one character at a time. I have tried this before with a group of people in the pub. Half of the people there had never done any Python, one person had never programmed at all. It went badly wrong, would be suffice to say. It turned into a ridiculous Stack Overflow question to see if we could get the thing to run at all. It'll either go that badly and you'll have a lot of fun, or you might even get it to work. So probably groups of 6, so if you get together, 2 groups of 3 together. If you get a solution right, you get 2 points each, everyone in the group. There is a folder called group in the repository, so you try the exercises from that. And we've got about 15 minutes for you to have a go. So go for it. Yeah, you're going to have to go around. You've got to do one from group. So would you like to calculate a median? do the nth Fibonacci number, or slightly, quite a lot easier, reverse some words in a string. Remember, you can still do backspace, so if the person before you does something utterly ridiculous.
So if we need to delete a whole line, it's going to be like...
Yes.
So long as you have a majority of the people in agreement with deleting what the
Right.
other people have done.
See if you can do a median, if that's all right.
Which one have we got? Median. I think you should shout out the letter into the microphone as you press it.
Yes, I agree with that. Okay. So in this one, we're writing a function f, which, given a list of numbers, calculates the median value. If the list is empty, return none. As Thomas just suggested, this is power mode, which means you need to shout out the letter you're typing as aggressively as you can, and then move on. And I think we're just going to rotate around the stage like a conga line. So.
There's just about enough room that you can sneak past back here if you want to.
No, let's just jump off the stage and go around, I think.
It's probably easier.
So we have our order sorted out. We don't get to communicate once we start.
Okay, all right.
So
this is the order.
this is the order. No, you one backspace and then you've got to go off, and the next person has to do.
Yeah, one key press, so you can do a backspace. No, but it's one slide. Or can it be four?
Four is fine. Just do four. I mean, if there are people sitting here that are not joining in, then have them join in. So we can't have there are some people sitting No. D, we've started. Go.
E. X. No, just kidding. F.
F.
Open parentheses.
N.
Close parentheses. Let's go.
I just get the white space characters.
The white space is okay?
Yeah.
Or?
Yeah, we'll let the editor do auto completion because
Okay.
we can see what we're doing with this one.
Yeah, that makes sense.
Oh, that's the time to think. N.
S.
Steve knows what I'm thinking. Goes against all of my good development practices.
I have no idea.
Code doesn't have to be good, it just has to work.
I have honestly no idea. So.
You can put a space in the next person with backspace in it.
Yeah, that's communicating, but yeah, I was thinking along those lines.
Okay. Backspace.
I think it's this. I think it's real unfortunate for everyone.
Can I look at the Python build?
I think if you can get or something between your key presses, then
R.
T.
Open paren.
Should I be after the...
You can delete the close paren if you want. That one got added automatically, so there you go. Oh, it was. That's right. Yeah. Python added it one.
Yeah, okay. But I guess I'm a bit confused. Close paren.
New line.
Backspace.
Tab. I.
F.
Space.
O.
T.
Space.
I feel like this is just getting more confusing every time. Well, space.
Okay, let's do backspace.
Colon.
New line. R.
E.
D.
U.
R. Oh, sorry.
N. New line.
R.
E.
E.
Backspace.
Oh, backspace, good. U.
R.
N.
Space.
N.
Space.
Open square bracket.
I have no idea what we're going to do with the square bracket. Backspace.
I think another backspace.
Square bracket.
L.
Backspace.
Backspace.
Discuss it one character at a time. Period.
You know what? Sorry. I don't. Never mind. Just space.
Backspace.
I wasn't confused unless you deleted my L in brackets.
I'm confused about whether I've spotted something that other people haven't, or whether other people have spotted a way of avoiding a problem that I haven't.
Well, I gave a chance to others. Space.
Backspace.
Backspace.
I'm trying to give you a hint here.
We've got about 5 minutes left, so yeah, good luck. I've been asked to give a hint to this team, which I guess I'll do. I'm feeling nice. Look at the second test case that's been requested by one of your team members.
Well, so I'm meant to be looking at the second test case. I think we're clearly not, because I've been exactly here before. Backspace.
And
Backspace. I concur now.
Maybe you should be like one key combination. So somebody can highlight shift component. Yeah. And then
Thomas, let's just do that and get it done. Yeah, okay. Whatever happens.
I'm sorry.
Yeah, the second test. Okay, press something, because we need
Space, sorry.
Oh crap, how do you do this on a Mac?
Uh-oh. That's...
I think we can.
Hey, you shifting. It's okay.
Tab.
That's true. New line.
It is, well, it's by one definition of median, and it's the definition that we have to do. Remember the definition of median? Yeah. It's what?
So the second test case.
Okay. It's going to be a lot of typing.
So maybe it doesn't have to be good.
You can do it this way.
Well, can we establish the definition to make sure we're on the same one?
So the definition of this median is the centric value, there's an odd number of values, or the mean of the two centric values, and there's an even number of values. So if there's an exact one in the middle of the list, that's the median. If there are two equally, because there's an even number of elements, you take the mean. That's what it's doing. In some definitions you take the lower one, some you take the higher one, in some you take the mean of the two, and we're taking the mean of the two in the middle if there's an even number of elements.
L.
E. Tab.
N.
Okay, what now? Closing parentheses? Or
Yeah, colon. Oh, sorry, that was a mistake. Space.
Percent. Oh, sorry. Percent. Yeah. Yeah.
Equals.
Equals.
0.
Colon.
Enter.
It's a nice way of getting it. R.
1 minute.
E.
T.
U.
Tab.
N.
Scrabber hack.
L.
Tab.
N.
Bracket.
Slash. Oh, sorry, slash.
Slash.
2.
Yeah, like 2 characters.
Okay, I guess, I'm not sure if this is going to override it, but I want to just close that. Yeah, okay. Closing square bracket.
Alright, last character and then we're done.
You want it?
Sorry. I'm down. I can run it and see how much you actually got if you want. Yeah.
Yeah, we got stuck in the...
It's 2 out of 6 passed. So, you know. Cool. All right. I'm afraid that is all we have time for. So if we can just sum up at the end and try and figure out who won. All right, cool. Thanks. So if I could just have all your attention for a minute, you can carry on playing afterwards if that's what you want. If we could just have quiet for a second. Thank you all for playing. I hope you enjoyed that. Thank you for Cambridge Medical Robotics for allowing me to be at the conference this week and run the session. So we are hiring. So if working surgical robots sounds cool, then please check out the website or come talk to me afterwards. So scores. I hope you all made a mental note of your scores. We're going in for a simple one. The winner gets this exciting Python Easter sticker I picked up at the O'Reilly desk yesterday, which I've written EuroPython Python B champion on. So it's an ultimate prize. So if everyone puts their hands up, and then if you keep your hand up if you got the score that I'm about to say or higher. So if you all lift your hands up. Okay, 1. Excellent. 2. Right, we have a joint winner, both on 1. I suggest you take half of the sticker each. A round of applause for our winners. I will leave your sticker here. Congratulations. So yeah, I hope you all have fun. You can play this anytime you like in a pub or in the hallways afterwards. Yeah, hope you enjoyed it. Thanks. It's been the most ridiculous thing I've ever got a room full of people to do. That's all right.
like half a minute. Okay, so next up, Daniele Rapati will tell us why he doesn't like Mondays. Please give him a warm welcome.
Hi, I'm Daniele. I work for Not on the High Street in London. Not on the High Street is a marketplace for small creative businesses. We are in Richmond. Richmond is one of the best parts of London. There are incredible parks and riverside pubs. And it doesn't feel like London at all. It feels like a country village inhabited by like ambassadors and rich bankers' wives and tech companies. Also, Richmond is where the Rolling Stones formed, and some of us care a lot about the Rolling Stones. This is a talk about being on call, carrying a pager, being available 24. If you are a DevOps or a developer, you might already know something about this topic. If you are a data engineer, I'm going to make a case that you should care more about this topic. But I will also talk about a TV show, and there is an embarrassingly high number of pictures of my cats. And it's a Friday afternoon talk, so I'm going to warm you up by asking you questions, and you're going to raise your hands to answer. Who is on call right now? Good. Who was on call in the last month? Who was actually called in the last month? Okay, if you did raise your hand the second time and you didn't raise your hand the third time, well, you're living the dream. Money for nothing and chips for free. On the menu for you today, we start with light definition. We move on to some mixed advice on what to do during an actual incident. Then we have our prevention special. And then we move a bit with a farther view, and we talk about motivations and alerting practices. And in the spirit of total transparency, I have a couple of stories to follow. And luckily enough, one was from last week. So some of you already know, but being on call means you have a phone, used to be a pager in the 80s, and when it rings, you need to go and fix the system because it's broken. Another way to think about it is basically you have something that is with you at all times, and you need to care about it, but secretly it hates you, and it will demand your attention at the most inopportune times. And when it wants your attention, you have to really give it immediately. But being on call is also about knowledge, about being the first person who will act on a certain system in case of a problem. So you get to know an entire system, not only just the parts you did develop. And you will also get some rewards because you deserve them. Rewards like being woken up in the middle of the night. So last Thursday, my phone rang at about 1 a.m. And before you get to your computer, you want to make sure you are awake. You're fully awake, so make some tea, make some coffee, walk off the sleep a bit, a transition, like going from your sleeping self or your working self, if the incident is during office hours, to your incident self. So you don't want to be the guy who is developing on one window and fixing production on the other window. That just, the incident deserves your full attention. And the first thing you do is you're going to read the alert that woke you up. Like, really read it. At least a couple of times, possibly more. Once you've read it, you probably know where to look. Like, which system broke, where can I find the error logs, where can I find the monitoring data. And you want to gather as much information as you can until you can basically be sure of why did this alert trigger? Like, what did wake me up? And at this point, you probably have enough information to assess the impact. What is going to happen because of this problem? Who is not going to be able to do their job? Who is not going to be able to know something they want to know? And be nice. If people are impacted by the problem, inform them. Most websites have status pages. For internal systems, you probably have an email or a chat tool. And there is a question you might find yourself asking a lot, which is why? What is the real deep cause of this problem? And this is not the right time to answer it. If you are going to dive into, with your developer mind, try to find out the real root of cause of the problem, you're going to spend a possibly very long amount of time, and you cannot quantify it. So don't do it. It's not productive at this time. And as you find out informations, as you start acting on the system, log what you're doing. So this is on a chat app, it's Slack, but you can also just open a blanket email to your team and start typing out what is happening. This is invaluable information, especially if you're preparing a talk on being on call. And once you have enough information, you probably can come up with one action or a few actions that will limit the impact as much as possible and are safe. So if we scroll back, and you probably squint a bit because I'm not sure if it's readable, you're going to find out that I did not follow my own advice. And last week I ended up forking a library at 4 a.m. and trying to patch it. It did not solve absolutely anything. And that's because instead of focusing on taking the smallest piece of action, I actually started asking myself why. And that was not useful at the time. The action I should have taken, which we only took in the morning, was just to skip that data integration step. True, we wouldn't have known on the day after what the sources of our traffic were, but at least we would have had all the rest of the data in time. Once you've taken enough steps to limit the impact, again, be nice, inform the people who are impacted, and then get back to sleep. Because you want to be fresh on the next day. Usually, you wake up the day after, and your first thought in your mind is, this is all pretty stressful. I don't want it to happen ever again. And at this point, you can really ask yourself why this error occurred. And the best way to do it is an RCA. There is best practices and extensive literature on RCAs, so I'm not going to dive too deep, just one slide. You want to put your detective hat on, gather all the information on what actually happened during the incident and before the incident, find the root causes, and be sure to leave enough time at the end to decide on some actions that will mitigate those root causes. And it's very easy, in this case, to try to blame someone. Don't do it. So I'm going to tell you a story. It's about a nurse in a childcare hospital. She gave the wrong drug to a little child, and the child almost died. So an inquiry was opened, and there was a proposal to fire the nurse. But then the commission on the inquiry dived a bit deeper, and they found that the drug she should have administered and the drug she actually administered were one next to each other in the same cabinet, and they had similar labels. And they also found out that the nurse had been working 10 hours straight, and there was nobody to double check what medicines, what drugs she was administering. So don't allow yourself to focus on the fault of one person. Always look at the context. And from an RCA, you usually get some useful lessons for the future. You probably are already familiar with this. Be really careful where your systems talk to a third party. And because communication is more scarce and more easily ignored. And watch out for point of friction in internal communication as well. So the root cause for last week's failure was that the GA reporting API has a time on site field, and they renamed it to session duration, and the old name was deprecated in 2014, but they actually started enforcing the deprecation and failing on API calls last week. Another insight is to really care about your error messages. Keep them up to date, make sure they include everything that can help you during an incident, so checklists, lesson learned, encouragement. So we took 3 actions. We fixed the root cause of the problem, we renamed the time on site to session duration. We scheduled some time to go through all the GA fields that we are using and check if any other of them is deprecated. But we also included in the alert message a specific suggestion not to do what I did. So just skip the step. Don't try to dive into causes too much. So let's take a step back to 2015, and let's take a broader view. Downton Abbey is a TV show about a wealthy aristocrat British family in the first half of the 20th century. It is wonderfully acted. The sceneries, the costumes, the settings are amazing. And it's really on target for Not on the High Street. It's very British. It's so much on target that when we placed a TV advert during the first episode of the season, on a Sunday evening in October 2015, we had so much sales and so much additional traffic that the site went down. It recovered, and then it went down again when the same advert aired on the +1 channel. On one side, I was sort of lucky because I was not directly involved with the consumer website. But on the other side, the situation on the data infrastructure, which I looked after, was a lot worse. So we had basically no data since Saturday morning because the replica of the production database we used to read from was offline. We were in the process of migrating between hosting providers, and there hadn't been enough communication on when the replication between environments will stop. And the only person who could really fix all of this mess was our databases and networking expert, DevOps. And he was on a plane back from Russia. As soon as he landed, like late Sunday evening, His phone rang so many times that by the time he got home, his battery had drained down. Why did we care? 2 incidents at the same time, one on the consumer website, one on the data infrastructure that we would have used to evaluate the impact of the consumer website incident. And it was a Sunday evening. So the next day is a Monday. On Mondays, our data infrastructure sees the most usage because it's both the busiest trading day and also the day where we plan for the week ahead. I do not like Mondays. And this was not a normal Monday. At the time, we were a lot more inexperienced than we are today. And we learned a lot from these events. We learned as an organization, we learned as a team, and we changed. So let's talk a bit about the changes we made. How do you answer this question? Well, you look at consequences of an error. Who is affected by the service or the data being unavailable or wrong? Do they depend on your service? How much will it cost? How much time can they wait for the information? In 2015, we were realizing that our coworkers and our colleagues were increasingly dependent on our data infrastructure, especially for decision making. So if you have a public-facing service or a public-facing website, you probably want to consider some kind of on-call policy because you cannot control how much the external people depend on your service. And you might also have a contract in place, or your revenue might depend on the external service. In 2016, we started offering to our partners, the people who sell on not on the high street, access to a rich dashboard with sales figures and product performance, and at that point we didn't have any space to roll back the on-call policy. But even if you just have an internal service, you should consider on-call because you want your coworkers to spend less time and worry less about checking and double-checking that the services are available. And if they spend less time doing that, they will get benefit in their daily work. If you take a step back to Downton Abbey and you sort of know the characters, it's not about just keeping happy. You also want Daisy, the assistant cook, to be the best she can be at her job. And you might pay this increased in trust with a little less control on your priorities and a little less agility as you need to react to incidents. But in the end, it will be worth it because you are enabling others to rely on your tool, and your stability will enable their success as they build more and more on top of your data and your tools. And you will be surprised by the brilliant creative ways in which they can use the service you provide. Enabling others. Nothing else matters. So, it's worth it. We decided it's worth it. How do we make it work? What did we do in the days, in the weeks, and the months after the Downton Abbey debacle to make sure that we could fix problems in time? Usually, the very first basic is getting an email when a certain program fails. That's the real basic. And that's what we had at the time. Then you can build on this email. You can attach certain tools that will phone and wake you up. And you can even do it yourself with Twilio if you want. And then you can also send lower priority alerts and messages to your chat or to your internal communications, so that you have a timeline of there was this low priority alert, then there was this high priority alert, and this is what happened, and it's all in one place. And in this phase, you also want to be making sure that the person answering the incident, responding to the incident, is able to do it. So make sure your logs are accessible, make sure there is documentation in place, consider training people with fake emergencies and fake incidents. The next step up in the chain is moving from gathering information just when bad things happen to gathering information all the time. So you can start with very basic information, CPU usage, RAM usage, disk usage, and then you can move up and take a broader view. How many web pages are we serving? How many jobs are running? How much data are we moving? And then you can even move even higher. How many customers are we serving? How many orders have been placed? And at this point, you can plug your alerting system on top of your monitoring system, rather than just getting an alert and getting paged when there is a problem. You can say, okay, I have a CPU, all CPUs at 100% for 10 minutes. Maybe it's time for an alert. Or I have only 8 megabytes left on my hard drive. Maybe it's time for an alert. An even higher step up the chain is looking at your monitoring, at your business data, and monitor that data itself. So you're looking at questions like, is 20,000 customers on the site normal for a Sunday evening? Have we received the data we expected from Google Analytics? Do we have a high rate of traffic that doesn't have a Google Analytics identified source? And this works really well because it's basically an alerting system for both your business and your systems. There is a lot of literature on data quality, sort of tainted by association with some well-known big software vendors. But if you discard the big software vendors, these concepts are actually general and they don't depend on specific technologies. So now we have lots of checks and alerts. Some require immediate attention, some require attention on the next day, some require attention on the next working day. And you maybe start ignoring some of them. Don't get comfortably numb. Read each alert. Make sure the team reads each alert. Respond to each alert. And also examine if that alert was useful. Can you improve it? Should you silence it? Should you measure something else? And then classify alerts. Classify them by system, by kind of problem, by business area, by priority. Ideally, every new feature or every new bug has monitoring and alerting attached. And over time, you can use information you gather this way to guide your decisions. Guide your technical decisions, guide your product decisions. So I have a very opinionated selection of resources. Blog from Julia Evans, a conversation on Twitter with Charity Majors, the nurse stories stolen from this course on business ethics. I cannot recommend this course enough, even if it doesn't almost cover on call. It's a really good course. And the last one is a 2013 book on data quality, which still holds well enough. So I just want to say thank to all the DevOps and engineers and developers who have been on call for years and make the internet work.
Thank you for your presentation. And now for questions and answers.
You've mentioned training people with like fake emergencies and stuff like that. Like, how do you simulate that? Do you actually like break something on a staging environment, or what do you do to get
I
that?
actually break production on purpose during office hours. That's how I do it.
Nice.
I'm not telling you to do it, but that's actually how we do it in my team.
When you're continuing on this, when you break on production, do you have also an alternative backup system, or?
It depends on the breakage. If we are causing a breakage on purpose, we tend not to do something that will actually go to the customers. So maybe we put a wrong string for the connection database, and then we make it fail before it deploys. So that we tend not to do anything that will actually impact people. I also look after a lot of ETLs, so you can make an ETL fail in the middle of the day, and the data will still be the same data you gather at the beginning of the day. So that's another way to do it. That's mostly how we do it, actually.
All right, thank you.
Any other questions? No? Oh.
It's kind of unrelated, but are those your cats?
Yes, yes. The gray one is Estia, and the white one is Philo.
Thanks, and I know what you feel when they call you. And which kind of software do you use for monitoring your either your system or your data?
So this layer is Datadog. They have a booth just right outside. For this layer, we use a data democratization tool called Redash. It's a wonderful tool, and I strongly encourage you to try Redash. It's in Python, by the way. Obviously, there are alternatives. There's as much as alternatives as you can think of.
Okay, do we have another question? If not, we can thank our speaker.